Good day and welcome back to the Johnson Space Center as our pre-flight briefings continue for Discovery's upcoming flight to the International Space Station. This is the mission overview briefing. With us today to discuss all of the details of this flight are Brian Lunney, the lead Space Shuttle Flight Director for STS-133, and Royce Renfrew, the lead Space Station Flight Director. And we'll start off with Brian.
Let's see. Good morning, folks. We're excited for this upcoming mission. I'm really grateful that all of y'all have taken the time out of your day to come talk to us about the mission. Hopefully we'll fill in all the questions that are in your minds and be able to help you understand what's coming on this mission. If I could have the crew picture of the crew up there, we'll talk about the crew who's flying. We have a great crew. They've flown numerous times before as a group. We're looking forward to working with these guys. We've had some great training sessions over the past number of months, and they're a great group. Starting with the picture on your left, we have Al Drew. He's flown once before in STS-118. This time around, he'll be one of our 2 spacewalkers. And while he's not out doing spacewalks, he'll be inside helping with everything else. Particularly, he'll be assisting with the shuttle RMS operations during the Flight Day 2 inspections, the Express Logistics Carrier installation, and also the Flight Day 10 inspections. And we got him doing a bunch of other things as well. Next to Drew is Nicole Stott. She, of course, has been a flight engineer on Expedition 20 and 21. She flew up on STS-128 and flew back on STS-129, so she's an experienced flyer all around. She will be performing robotic ops with the station RMS for installation, excuse me, for installation of the Express Logistics Carrier as well. And she'll also be doing the coordination of the spacewalk tasks from inside. So she'll be walking the crew outside through all their tasks, every little detail. You'll hear her telling them, reminding them what they're supposed to be working on. Next to Nicole is Eric Bowe. He's our pilot on this mission. He is a pilot from STS-126, so he's flown once before. Eric will also be performing robotic ops with Shuttle RMS during the Flight Day 2 inspections, the Express Logistics Carrier install, and the Flight Day 10 inspections. He is also scheduled to help us with the permanent multi-purpose module outfitting. Once we get it installed, he'll go hook up all the wires and plumbing to make it work for us. And that we expect that activation to occur about Flight Day 7. We may shuffle that a little bit earlier if things go well. Eric will also pilot Discovery during the undock and fly around at the International Space Station on Flight Day 10. Next to Eric there in the middle is Steve Lindsey. Steve, of course, is a very experienced flyer. He was pilot on STS-87 and STS-95. Then he was commander on STS-104 and 121. Of course, he will fly the rendezvous for us, and he will be assisting with the shuttle robotic operations as well, and he'll be available for a lot of other tasks throughout the mission. Fifth from the left there is Mike Barrett. This is Mike's first time to fly up on the shuttle. When he was an expedition crew member on 19 and 20, he flew up on the Soyuz. Once up in space there, he will perform a lot of the space station robotic operations for us during the Express Logistics Carrier installation, the permanent multi-purpose module installation, and also while the spacewalkers are out doing their business out on the outside of the vehicle, he'll be flying the station robotic arm around, helping them get to various locations. And finally, on the far right is Tim Copra. He flew up on STS-127. He was a flight engineer on Expedition 20, and he swapped seats with Nicole on STS-128. She stayed, he came home. Tim will be the other one of our spacewalkers on this mission. He'll be performing robotic ops also with the station RMS for installation of the ELC and the permanent multi-purpose module. These guys, like I said, are a very experienced crew. They've been having great training so far, and we know that they're all ready to go and fly this mission. They're in good shape to go fly. If I could get the crew patch up, we'll talk about that for a minute. This is a really neat crew patch, I think. It was designed based upon some sketches from the late artist Robert McCall. They were the final creations of his long and prodigious career. It shows Discovery lifting off with the plume beneath it, but there's no external tank and no SRBs, which is just representing sort of the tail end of the program, I think. But it's a sort of a retro patch, I think of it as, and I think it looks really, really nice. I like this patch. Let's see. If I could, we're going to talk a little bit now about some of the folks on the ground who will be helping the crew from get through their daily operations. If I could have the picture of Mr. Jones up. Richard Jones is our Ascent flight director. He's known as Sigma Flight. This will be his 4th Ascent. And of course, Richard, he's very experienced. He's ready to go. He'll be doing his final simulation with the Ascent team next Tuesday, and then they will be ready to go fly, help the crew get off the ground on Ascent Day and turn that vehicle from a rocket launcher into an orbit operations vehicle. Next slide, please, with Ginger. Ginger Carrick is a Vega flight. This will be her third flight as a shuttle flight director. She's done numerous things on the space station side and still is doing those things. Ginger will be on the Orbit 2 team, which is the team that's sort of in the second half of the crew day. So after lunch or thereabouts, she will take over with her team and help the crew through the spacewalks and the other operations during that phase of the day. Next slide is Rick LeBrode. Rick is a Pegasus flight. This will be his 8th flight as a shuttle flight director. He too has worked a lot on the station side and also on the shuttle side. He's a very experienced flight director. Rick will be working the planning shift, which will be the overnight while the crew's sleeping, and they will work any replan efforts that might be required, but basically get the plan on board for the next day for the Orbit 1 and Orbit 2 teams to go execute. And then finally, on the shuttle side, I'll mention Paul Dye. Paul is our Team 4. Of course, Paul is Iron Flight. He's very experienced. Y'all have seen him numerous times as a lead. He will be, the Team 4 folks are there just in case we have some issues, and they can come in. We had pre-identify a Team 4 folks to come in and work any issues that may come up that the flight control team may need a little extra help with. So we're excited to have Paul helping out with that. Hopefully we won't need him, of course, but he'll be available if required. Let's see, and last but not least, for entry, for the final landing there of Discovery, we have Tony Sakachi. He is Intrepid Flight. This will be his second flight as an entry flight director. Of course, he has numerous leads also and has been in the shuttle program, I think since STS-1. So he's been around a long, long time and very experienced and brings a lot to experience to the console. And we're really glad that he'll be helping us out with the entry phase of this flight. Finally, for myself, I'll of course be Orbit 1. I probably should have mentioned that already, but we'll be working, my team will be working the first half of the crew day. We'll get there about the time the crew wakes up, and we'll be leaving around midday when the crew is going to bed. Now I'll walk you through a few of the things in the payload bay. If I could get the video for the payload bay. There we go. This is Discovery's payload bay. It shows all the elements in there. Up towards the front of the vehicle is the orbiter docking system. That, of course, is what we docked to the International Space Station with, and the crew will use that to transfer between the vehicles once it's pressurized after docking. There in the port sill is the Shuttle Remote Manipulator system. That's our robotic arm we'll use for numerous robotic operations throughout the flight. And the orbiter boom sensor system is on the far side there on the starboard sill, and we'll use that to inspect Discovery's heat shield. The Express Logistics Carrier number 4 there is in the middle. It's to carry ORUs for station, and that's the radiator sitting on it. I'm a little behind the video here. And the Permanent Multi-Purpose Module is there. You may recognize it as formerly known as an MPLM. We call it a PMM now. We're going to take it up. We're going to leave it on board International Space Station. So let me walk you through the flight days. I'll get the first 3, then I'll hand over to Royce and let him work on the rest. Of course, we're going to launch on November 1st. It's about 3:40 in the afternoon here in Houston, the time of launch. We're looking forward to that, ready to go. Mr. Jones will come in with his team, and they'll be ready to go execute and get the Discovery off the ground. Once Ascent is complete and we've turned the vehicle over into an orbit machine, got the payload bay doors open, they'll begin downlinking, and we're reviewing our Ascent imagery, of course, and pick up with some of the standard sort of Flight Day 1 activities. These include, we'll downlink all the video from the ET and the umbilical wells. We got some sensor data to play back. And the crew in general is going to be just configuring the cabin, putting away some seats, getting the cabin ready to go for orbit ops, and also pulling the arm out and doing a brief RMS checkout to make sure it's in good shape for the next day's activities. On Flight Day 2, the crew will wake up, and if I could roll the video of the inspection, please. There we go. I think y'all may have seen this before. This is the inspection video. They'll pull out the arm, and they'll do scans starting on the starboard side and the aft, just looking for any Ascent damage that may have occurred. And we'll do a pan-tilt survey there of the back end, including the OMS pod, checking for the thermal blankets and the towels and the T0 umbilicals, making sure everything's in good shape after Ascent. And then they will maneuver forward, and they'll do several racetrack patterns, scanning the reinforced carbon-carbon along the leading edge of the wings there, making sure those things are in good shape and that no damage was incurred during Ascent time. This process takes about 6 hours, so it's much of the crew day on flight day 2. The wings each take a couple of hours each, and then they spend the balance of the time working on the nose cap and the other surveys. And the crews train this a lot and obviously ready to go execute. It's the same survey we've been doing for several flights now. With all that data that is coming from the Ascent team, from the Ascent imagery on the ground that we downlink from the orbiter post-launch, and then this data, and as well as the R-bar pitch maneuver, all that data is going to be reviewed by the teams on the ground. The debris damage assessment team will gather all that data, and they'll look at it and compare it to baseline data. They're looking for any damage that may have occurred during ascent to be sure that the vehicle's in good shape. And after about a day and a half, sometime around when the crew's going to sleep on flight night 3, they'll be able to report to us if they require a focused inspection. So if they see something of concern, they want to get a better look. We got some specific instruments on that orbiter boom system for that. We'll go and have a look at any area that they might be concerned about, and we would do that on flight day 6. If that's not required, of course, we get a clean bill of health from them. We'll be very excited. And that, frankly, is our anticipation that the vehicle will be in good shape. Once they tell us after flight night 3 if a focused inspection is not required, that team, the damage assessment team, will continue to do their reviews and then report to the MMT after a couple more days, probably of more rigorous analysis, comparing all the baseline, making sure everything's just completely good. They will report to the MMT their report, and based on that, we hope to be able to clear Discovery's TPS to be safe for entry. And of course, you'll hear that from the folks when we come back in here on those days. I know you guys have followed these debris assessment, damage assessment things from flight to flight to flight. And lately, they've been very, very clean, and we're very excited about that and have every expectation that this one will come back just the same, very clean. And we'll be able to execute the rest of the flight nominally. Let that video play out. Once they're done with the scans, they're going to go ahead and park the OBSS. They'll put it back in its place on the starboard sill, and then they'll put the RMS, shuttle RMS, over in a pre-cradle position, getting ready for docking on flight day 3. For this inspections, of course, I mentioned them already, but I'll say it again. Steve, Eric, and Al are all trained and qualified and ready to go execute these inspections, and we'll see which one of them actually flies the arm, who helps, and which roles they play, but I expect they're going to swap out a little bit as they go. And there you can see in the videos being parking the arm, ready for flight day 3, excuse me. So again, overnight, flight day 2, we're looking at all the data. The ground team, the engineers on the ground are rigorously analyzing it, making sure that Discovery's in good shape, heat shield is in good shape. At the same time, the morning of flight day 3, we're going to wake up, get the crew ready to go rendezvous with the International Space Station. The crew should wake up about 40 miles short or behind the International Space Station, and we'll execute a series of burns to bring us up closer. And if I could roll the video of the approach and docking. And as they're coming in to the International Space Station, you can see them coming up from the bottom there. Commander Lindsey will stabilize the vehicle on the R-bar, which is just directly beneath the International Space Station, about 600 feet or so. And he'll do a R-bar pitch maneuver. And the folks on board the International Space Station will take a bunch of pictures of the TPS on the bottom, being sure that the tile there is in good shape. They'll get several pictures of each location, and with the 408mm lenses that they use, they will get really good pictures. And again, the damage assessment team will go and review all those pictures from the different angles that the pitch maneuver actually enables, and be able to determine a whole lot of data about the health of the underside of the vehicle. And again, report back to us on the night of flight night 3, then a couple days later. And then we'll fly up to the V-bar. It takes about 10, 11 minutes to fly up there. Then Commander Lindsey will fly it down the V-bar corridor, approaching the International Space Station from out in front, so to speak. And then he'll pause at about 30 feet and do any fly out that might be required if there's any slight misalignment a degree or two. He'll be able to do that, and then press on in from 30 feet for the docking with the International Space Station. Once we are docked, the crew will commence with their hatch leak checks, make sure that the seals are all clean and holding pressure, and then they'll be able to open the hatches, go into the International Space Station and greet the crew on the other side. They will have a safety brief, and then they'll pick up with their activities with the International Space Station for Flight Day 3. And as I said before, it's a busy day. Half of it's done, the second half is coming, and Mr. Renfrew here is here to tell you about the second half.
Good morning. So 133 from an ISS perspective represents the last pressurized module we have scheduled to bring up, and also the exposed logistics carrier number 4 coming up. PMM will provide us with some much needed stowage space once we move all of the equipment out of the PMM into the various locations on ISS that it comes uphill with. There's some good science and lots of spare parts in there, and then once we get the module cleared out after 133 departs, we'll move other equipment into the permanent multipurpose module. That is equipment that we don't normally have to get hands-on very often. It's been a pretty busy traffic pattern on board ISS, as it has been for the last couple of years. On October the 10th, we docked 24S with our last 3 ISS crew members that came up. On Tuesday of next week, 37 Progress will undock from DC-1, and then on Friday of next week, 40 Progress will dock to DC-1, bring up additional materials in that vehicle. And then also after 133 undocks, the 23 Soyuz vehicle will undock at the end of November. I should point out, and I think it's been mentioned a couple times in the conferences already, that November 2nd represents 10 years of continuous human presence on board ISS. Some trivial pursuit facts and figures for you. On November 2nd, we will have had 68,519 total orbits since the first Element launch, and we'll also have had 57,361 total orbits with humans on board ISS. Some of the prep work that's gone on to get ready for the mission: we've installed a power cable in the lab that will allow us to provide power to the permanent multi-purpose module once we get it installed on the Node 1 Nadir port. We've also checked out the starboard lower inboard common attach mechanism where the express logistics carrier, number 4 is installed. Done a lot of work in the airlock, recharging various batteries. We've also moved the 4 spacesuits that we usually keep on ISS out of the airlock into other locations on ISS. 133 will bring up its own spacesuits, and we'll put them in the airlock after we get docked. We've moved the special purpose dexterous manipulator onto its location for 133, which is the lab base point. And we've also gotten the space station remote manipulator system, the Canadarm2, walked off to the Node 2 base point. We still have 1 mobile transporter translation to do that on Friday and get the MT to worksite 3 for its start point for the mission. Crew's also spent a lot of time. Brian showed you the pictures of the R-bar pitch maneuver from his perspective. The crew has spent some time on board reviewing those procedures to be able to take those pictures with those 400 and 800 millimeter lenses to make sure we get all the orbiter TPS inspections done. And we've moved some stowage, and actually Brian and I were just in a tag up with the crew when before we came over here. We've had several tag ups with the crew and several more scheduled before we launch. Speaking of the crew, if I could get the crew slide, please. 6 crew members on board ISS at this time. From your left to right, we have Oleg Skripochka, Alexander Kaleri. Alexander is one of the most senior astronauts, cosmonauts in the world. He has numerous missions that he has executed. Then on the far right, we have Fyodor Yurchikin. There are 3 Russian crew members during the 133 mission. Will spend some time preparing for a Russian segment EVA using their Orlan spacesuits, which is going to occur shortly after 133 undocks. So they'll be doing essentially the same activities the U.S. crew members have been doing this week in preparing their spacesuits to go out. Third from the left there, you have Scott Kelly. Scott will be the ISS commander for increment 26 after Doug Wheelock leaves. A couple of activities Scott will perform for us. He has CEDRA, which is the carbon dioxide removal assembly, and we're going to bring up an adsorbent bed to replace in CEDRA, so he's going to do a majority of that activity for us. There's also a valve in the Columbus module in the internal thermal control system that we're going to R&R, and Scott's going to perform that. And he is also responsible for getting the Node 1 Nadir vestibule outfitting done along with shuttle pilot Eric Bowe. Next to Scott there, you see Doug Wheelock, who is the increment 25 commander, the current commander of the vehicle. Doug will also help out with that carbon dioxide removal assembly bed R&R that we're going to perform. And he's also going to make sure we get all the EVA camp out prep and post activities completed as well. Next to Doug there is Shannon Walker. Shannon has various in-flight maintenance activities that we're going to perform on 133 with either items that we're bringing up on the vehicle that we need to get installed on ISS or items that we want to bring home on 133 that she's going to take apart for us. She's also spent the 3-stage EVAs flying the station arm, so we're going to use her expertise in that area to work with Mike Barrett during the 2 EVAs where we're flying a crew member on the arm. Shannon also has a couple of individual unloaded arm ops that she's going to do for the various walk-offs that we need during the mission. If I could get the first flight director slide, please. We'll roll out of the crew overview, and I'll tell you the folks that are on my team on the ground. First person there is David Korth, who's Odyssey flight. Dave's the other execute shift flight director. He gets the Orbit 1 shift, which is essentially the first part of the crew day. That'll include EVA prep on flight days 5 and 7, and also all the activities that are associated with the morning ops, which includes the permanent multi-purpose module installation on flight day 6. You've seen Dave as the STS-119 15A ISS Orbit 3 flight director, and he was also recently the Increment 2122 lead ISS flight director. If I could get the next slide, please. Chris Edelin is the Orbit 3 ISS flight director, the planning shift. Chris will be responsible, and Chris is venture flight, by the way. He'll be responsible for making sure any changes to the plan are taken care of that we might need based on real-time decisions during the mission. He'll also be responsible for a lot of those robotics ops I've alluded to that are going to occur when the crew is asleep and the ground is driving the arm or the MT from the ground. A lot of that will fall on Chris's shift. You've seen him recently as the Shuttle Orbit 3 flight director for STS-130, which was ISS-20A, and he was also the Shuttle Orbit 1 flight director for STS-132, which is ULF-4. Next slide, please. Kwasi Alabarujo, Defiant Flight, will be our ISS Team 4 flight director. Kwasi's a veteran flight director with numerous missions. His last 2 leads have been the ISS lead flight director for STS-119, which was 15A, and he was also the shuttle flight director lead for STS-130, which was 20A. Going to go through a couple snapshot configs of the vehicle as we work through the mission, and then I'll talk about the 2 components that we're going to install, and then we'll get back to the flight day overview. So if I could get the first overall config. This is what it'll look like after Discovery gets docked to the ISS before we start any of the installations. And then on the next slide, you can see ELC-4 installed out on the starboard truss. We'll do that on flight day 3. And then the next slide, please. Here's the location of the permanent multi-purpose module docked to Node 1 Nadir. And then if I could get the next slide, please. Here's what the ISS will look at after we're finished with the mission and we're back free flight. The permanent, let me spend a little bit of time talking about the permanent multi-purpose module and what it is and how it wound up here. If I could get the exterior shot of the module, please. Here you see what's called the permanent multi-purpose module, and the red area over there is where it's located on Node 1 Nadir after we get it installed. As Brian mentioned, this is actually a multi-purpose logistics module that has flown to ISS numerous times. The last time it was on board was during STS-131, which is 19A. This is the Flight Module 1 Leonardo module. After we got it back from that mission in April of 2010, we upgraded some of the exterior micrometeoroid orbital debris shielding, and we also changed some of the components inside to make it easier to do on-orbit maintenance and updated the software on it, got it ready for a long-duration mission as opposed to the short turnaround MPLM flights. If I could get the next slide, please. Inside the module, again, you'll see as I go through these slides here, it comes uphill pretty much packed. One of the items that we're bringing up in the Bay 1 area is a treadmill replacement for the treadmill 2 or the Colbert treadmill. If we have any problems with that, we're bringing up a spare treadmill inside the permanent multi-purpose module. If I could get the Bay 2 slide, please. Here you can see where part of the Robonaut will be located. This is the stand that it sets on once we get it deployed in the lab. Then in Bay 3, We have Express Rack number 8, which is a payload rack. We'll get it out of the permanent multipurpose module after the mission, get it installed in the other modules and get it activated. It's a science rack coming uphill. And then if I could get Bay 4, please. Bay 4 shows the upper torso, where the upper torso of the Robonaut will be stowed going uphill. And again, after the mission, we'll get those two components out, get those put in the ISS and activate that. And then the last slide shows the end cone configuration with a couple bags around the outside radius of the end cone. After we've cleaned out a lot of stuff in here, we'll build what the crew likes to call a bungee jail by stringing bungees between the racks in Bay 4 and creating essentially a spider web back there where we can put some light items in the end cone of the PMM for additional stowage. So that's the permanent multi-purpose module, and then I'll tell you just a little bit about Express Logistics Carrier number 4. So if I could get that slide, please. Here you see both sides of Express Logistics Carrier number 4 as it's configured to go uphill. The bottom of the image as you're looking at it there would be the piece that attaches to the truss. If you look along the bottom of the image in the left side view, you see 2 grapple fixtures that the various manipulators will get a hold of. And then on the top, in the left and the right side view, you can see a 3rd grapple fixture, and I'll explain to you in a few minutes why we have 3 grapple fixtures on Express Logistics Carrier number 4. Going uphill, we have the radiator that you saw when Brian showed you the Payload Bay overview. This is a spare radiator. We've seen after the pump module failure recently how important it is for us to have in situ spare parts on board ISS, so this will be a spare radiator for the external thermal control system if we ever need it. Then on the right-hand side, you can see that I have 5 empty flight releasable attachment mechanisms, or FRAMs. Those come uphill empty, and then on subsequent flights like HTV that I have designated here, we'll put various components in there, like the flex hose rotary coupler and the common transport carrier number 4 that go in those 2 positions. So we left off with ELC-4. Flight day 3, after we get the crew across the hatch and have completed the safety briefing and the welcome ceremony, we'll get down to installation of the external logistics carrier, Express Logistics Carrier number 4. We will be using the bottom handrails, we'll be using the trunnion grapple fixtures I showed you there, and I have a little video that I can show you. I said I would explain why there are 3 of them on there. Tim and Nicole will be flying the Canadarm2. Al and Eric will be flying the shuttle arm for this activity, and then Al and Mike will actually operate the common attach system once we get it installed. So if I could see video 1, I'll walk you through the installation of ELC-4. Start out with the station arm, reaches into the payload bay and grapples one of those grapple fixtures I pointed out to you earlier. Then we will maneuver to what's called a high hover position and then translate starboard to allow to present a grapple fixture for the shuttle arm to take the payload away from us. Then the shuttle crew will operate the RMS, reach over and take the payload away from us using the 2nd grapple fixture that I pointed out to you earlier. Station arm will release and maneuver to the mobile remote service or base system where we'll grapple. While we're doing a walk-off, the shuttle arm will maneuver the payload and present the 3rd grapple fixture to us, which is in a convenient place for us to get a hold of. From the ground, we'll change the ends of the arm, and then the station crew will pick back up, operating the Canadarm2 from the cupola in this case. Grapple the ELC-4, then we'll perform what's called an operator-commanded auto sequence, which is just a really big maneuver that will run in automatic. There is a camera on the end of the ELC that allows the crew to get good cues when we come in. We'll come into a low hover and then a pre-install, and then we'll install it with Al and Mike operating the common attach system. After we get done, we will release, and then overnight, I will mention that I mentioned Chris is going to be doing a lot of robotics ops with his team overnight. Overnight, we'll walk the arm off from the ground back to the Node 2 base point to set up for the orbiter room sensor system handoff that occurs in the morning of the next day. So flight day 4, again, we have the handoff. Mike and Nicole will be flying the station arm, the Canadarm2, with Steve, Eric, and Al all having some portions of the shuttle robotics during the OBSS handoff. And if I could get video 2 here, I'll walk you through this. Station arm grapples the orbital boom sensor system out of the payload bay, maneuvers to a hover, and then presents a grapple fixture to the shuttle arm. Shuttle arm will grapple, station arm will release, and then the shuttle arm will maneuver the boom to a clearance position. The shuttle arm will hold the OBSS for the remainder of the mission for doing all of those, any late inspection surveys that we need to get done. Also on flight day 4, we're going to take the carbon dioxide removal assembly out of the air revitalization rack in node 3 and get that in a temp stow location in the GEM module in preparation for the CO2 bed R&R later in the mission. Also on flight day 4, I mentioned Scott will go into the Columbus module and we will take out a water on-off valve. It's water on-off valve number 8, which is a valve that's contained in the Columbus internal thermal control system. That valve has failed in an open config. We're bringing up a spare valve on the mission. We'll change that out, bring home the failed valve on 133. Lastly, we'll get the crew into camp out. Tim Copra and Al Drew will spend the night in the airlock in camp out in preparation for flight day 5, which is EVA 1. If I could get the EV crew overview, please. So here you see our two spacewalking crew members, Tim Copra on the left, Al Drew on the right. Tim Copra will be the lead spacewalker for both EVA 1 and EVA 2, and Al Drew will be EV2 on those two activities. These will be Tim Copra's second and third spacewalks, and this is Al Drew's first and second spacewalks. Art Thomason, who is the lead extravehicular activities officer for 133, has an extensive briefing for you folks later on today where we'll go through and talk about what we're going to do on both the EVAs. So I'm just going to hit a couple of the high points. We have what's called the J612 connector, and the name just derives off of the schematic that shows which cable socket we're going to plug it into. So we have the J612 connector cable. It's a 10-foot extension that we're going to plug into the end of node 1 that'll get that power source out from underneath the permanent multi-purpose module once we get it installed on flight day 6. We will also go get the pump module that the expedition crews have located into the POA on the previous stage EVAs. The POA is the payload ORU accommodation that's a part of the robotics system out on the mobile remote servicer system. We'll go get that failed pump module and relocate that to ESP2. There is a camera stanchion that is located close to where we installed Express Logistics Carrier number 4 yesterday, and we need to actually move that camera stanchion out of the way in order to be able to access those 5 flight releasable attachment mechanisms that I described earlier. So we're going to install a little wedge at the base of that stanchion that'll lean that stanchion away from the ELC4. And finally, we're going to go install some what are called cedar rail stubs, pretty short little pieces of the MT rail out on the starboard end of the MT rail. We had previously removed those in order to be able to do some solar alpha rotary joint maintenance on a previous mission. We'll go reinstall those. Overnight again, after the crew comes back inside, we'll move the SSRMS back to the Node 2 base point from the ground. And then flight day 6 will start up with the permanent multi-purpose module installation. In this case, Tim and Mike will be flying the Canada Arm 2. There is no handoff required. This is a direct unberth. If I could get the next slide, or the next video, please. So the first thing we'll do is we'll reach into the payload bay, grapple the grapple fixture, and then maneuver the permanent multi-purpose module to a low hover. Once again, we'll perform an operator-commanded auto sequence to get the PMM into what's called a pre-install config. In this case, we also have a camera system that assists the crew in lining things up, but instead of the camera being on the permanent multi-purpose module, it's actually a camera that's installed in the window on the Node 1 Nader common berthing mechanism hatch. You can also see that we're going to get a very good view besides the centerline berthing camera system right out of the cupola, because we're going to install this right next to it. We will then release, and then the arm will maneuver to its start position for EVA2, which we'll execute on the next day. Brian mentioned the work that we will do before we get docked to survey the vehicle, if we have achieved a statement from the shuttle program and all the engineers that look at it by flight day 6 that says Discovery is good from a thermal protection system standpoint, that we don't need any additional inspections, then on flight day 6 we will activate and ingress the module. Otherwise, we'll activate and ingress the module on flight day 7. Also on this day, Tim and Al will once again at the end of the day get back into camp out in preparation for their EVA-2 on flight day 7. And flight day 6 is a second part of our carbon dioxide removal assembly, R&R ops. We'll get one of the absorbent beds out and replace it with a new one that we brought uphill. Flight day 7 is EVA-2. And again, Art Thomason will give you the details of that EVA later in the EVA officer's briefing. A couple of the points I'll throw out here is that the pump module itself contains about 10 pounds of ammonia that we need to vent out so that we can bring the pump module home on a subsequent vehicle in order to determine the failure case that caused the pump module to fail to begin with. We will also spend some time during this EVA recovering the lightweight adapter panel assembly, which everybody calls LWAPA, off of the end of Columbus to put that in Discovery's Payload Bay for a return to Earth. The lightweight adapter panel assembly has been the base location for numerous material science experiments recently, and there's an avionics box on that platform that has some of that additional science data that we'd like to get on the ground. Additionally, that platform will be refit and reflown for another payload sometime in the future. Also on this EVA, we'll be installing camera lenses on several of the robotics cameras. These are little protective lenses that go over the cameras. We'll install those on one of the Canadarm2 cameras, one of the special purpose dexterous manipulator cameras, and on the payload ORU accommodation, the POA that's out on the MBS. Flight day 8 is a half crew day, but we still have a couple of things we want to get done. By this time in the mission, we'll be ready to put the carbon dioxide removal assembly back into its rack in node 3. Should point out that we have 2 carbon dioxide removal assemblies on the vehicle now. The one in the lab will be running continuously. We've normally always run the vehicle with 1 Seadra, and now we have 2. So we'll take advantage of that to do this CO2 absorbent bed change out during 133 by taking one of those down. We also have our last-minute mid-deck transfers, and we have some packaging material that's inside the permanent multi-purpose module that we need to get out for return, to return some items home in Discovery's mid-deck. Then on flight day 9, once again, we have a half-crew day. There is a joint news conference on flight day 9. I'm sure all you folks will be interested in that. We'll do the farewell, and then we'll also get the hatches closed, get the vehicles buttoned up for undock on flight day 10. And from here, I'll turn it back over to Brian for the rest of the mission.
Okay, thank you, Royce. So we got the hatches closed on flight night 9, and we're moving into flight day 10. The morning of flight day 10, the crew will wake up. The hatches will be closed, so go ahead and execute the undocking. If I can go ahead and roll the video, number 4 there, to show the undocking. Our pilot, Eric Bowe, will fly the space shuttle out to about 400 feet along the V-bar. And then he'll execute, fly around to get some good pictures of the space station on the outside of that, and then we'll do a separation maneuver, and Discovery will depart the vicinity of the International Space Station. Once that activity is complete, then the crew will go ahead and pull out the OBSS, the Orbiter Boom Sensor System again, and they'll do an inspection of the wing leading edges, the reinforced carbon-carbon, as well as the nose cap. Mostly here we're looking for the micrometeorite orbital debris type damage, so we won't need to go back and look at the back side of the vehicle. We'll just look at the forward part and looking for any little kind of damage that may have occurred from some of that debris that may be flying around up there in orbit. Again, all this imagery will be downlinked to the ground. That same team of engineers who now knows exactly what Discovery's wing leading edges look like on orbit will go compare to that baseline, and they can do a bit quicker assessment because they have that baseline to look at. So they'll go look at all that, verify it's all good, and again report back to the MMT what they have going there, which obviously we hope is very little. The system should be all cleaned up. Once the crew is complete with the scans and the reviews there, they'll go ahead and park the Orbiter Boom Sensor System on the starboard sill. They'll park it for the rest of the mission, and then they'll park the shuttle robotic arm also for the rest of the mission. And there at the end of flight day 10, we'll be done with the robotic operations. And it was a very busy flight, as you saw, with the, both the station and the shuttle arms doing a lot of activities. Yeah, there it goes. Bring it on down. So once we're complete with that, the crew will go to bed on flight night 10. The next day, the entry team will come in, with Tony Sakachi and his team will come in to do the checkout of all the entry critical systems to verify that they are all ready to go for entry the following day. So they're in the flight day 11 entry checkout. We'll check out the flight control systems when we fire up one of the auxiliary power units to power the elevons and the speed brakes and all those systems that are critical for entry, and verify that those are all working just as they should be. We'll also do a reaction control system hot fire, verify that the primary reaction jets are working just fine, and any other final activities we've got to do, such as cabin stow, stow the KU antenna, and generally get the vehicle ready for entry the next day. So the crew will go to bed then, and on flight day 12, Tony Scotch and his team will come back in to prepare for the Deorbit Burn. For the Deorbit Burn, for this particular one, we'll close up the payload bay doors, just like we have every other time. And after flying around the Earth about 170 times, is what we're going to get with this mission, Discovery will come home for its last flight. Also on this flight, we have the boundary layer experiment DTO, and this is where we have the little half-inch protrusion on the bottom of the orbiter. I think Mr. Shannon spoke to you about it earlier. We're going to gather data around Mach 18, Mach 19 when we get the boundary layer transition, what thermally occurs with that little protrusion downstream of it, and what all the data that the folks get from that. They got the catalytic coating on some of the tiles don't have the coating. Be able to derive what's going on in those types of scenarios and play that into future programs. The final landing of Discovery will occur at the Kennedy Space Center on November 12th, about 10:39 Eastern Time in the morning. We're all really excited about this mission. As I think we've laid out for you, the folks are really ready to go. We've got a good plan to go execute. It will be a very busy mission, as always, but the crew is ready to go. The team on the ground is ready to go, and we're going to go fly this one and come down home safely on November 12th. I think that's all I got, Rob, if folks got questions.
Thanks, Brian. Thanks, Royce. We'll take questions here in Houston, then go around to the other NASA centers, and I believe we'll start off with Mark in the back.
Oh, thank you, Mark Carreau from Aviation Week. And I have two questions. One for Brian: what triggers the additional day if it's available to you, and what would you do? Okay.
In recent flights, we've carried consumables to allow us to stay an extra day while docked. It's a dock day since we have the SPITS capability. We call it a dock day. In some flights, there's things that are pre-identified. Well, this is going to be a real challenge, and we're kind of worried about that task, and we may need an extra day to get that done. On this particular flight, we really don't have anything on that list. Most of the activities are pretty well defined. We think we understand them pretty well. Of course, we'll see. But we've trained them. We're ready to go execute. So on this mission, there's no pre-identified task that is in question. Only the usual sorts of contingencies that might come up, some sort of damage during ascent, inspections, repairs, and or some of the other challenges we may have while docked, and what we want to help out the International Space Station guys with.
Thanks. I had a question on the changes to from Leonardo to a PMM on the external shielding. I was wondered, how did you determine how much shielding you needed for the multi-purpose logistics module to make it permanent, so to speak? Is it based on a length of time or a position on the space station? How did you sort of weigh how much to put on to deal with the risk? Sure,
and what we've done with the permanent multi-purpose module is upgraded it to get it to be compliant with the rest of the modules on board on the U.S. modules that are on the vehicle. What we did there is took the hard shells off after 19A landed, and took the Kevlar blankets that are underneath the hard shells and upgraded the amount of Kevlar that is in those, and then put all those blankets back in, put the hard shell back on. We have folks here that do risk assessments for us to look long duration, 10 years out, What is how often are we going to run into micrometeoroid orbital debris, and what is the amount of protection that we need to add to the module in order to be able to protect the module from being penetrated in that case. So what we've done is taken a module that's only been designed and look at all those risk assessments that's only been designed to be on orbit for 2 weeks or so, and expanded that to say if this same module was on orbit for 10 years, what would we have to do to upgrade it to make sure we're in a good config for that long duration mission.
Robert.
Hi, Robert Perlman with CollectSpace.com. I think to follow up with on Mark's question about Leonardo, just to verify, are there any constraints on the ISS crew once it's attached in terms of how they can spend time in that module? Does it have any difference from other?
No, there aren't any constraints on how much time they can spend in the module. I think the natural flow of activities in the module will determine how much time they actually do spend in there, because really it's for stowage and food and water and pieces of equipment that we don't normally have our hands on. So I don't expect them to spend a whole lot of time in there to begin with, but there aren't any constraints on that.
And also, just to fact check, is it retaining its name Leonardo, or is it called PMM, or what? How do we refer to it in stories?
I will refer to Mr. Navius on that because I don't know the answer. It's the Permanent Multipurpose Module.
Affectionately known as Leonardo. So it will retain its name Leonardo for the purpose of engineering documentation. It's the Permanent Multipurpose Module.
And for Brian, given this is the last flight of Discovery, is there a sense among the team that this is that this has an importance to it, that it is a last flight? Is there, or is it just we fly the missions and there's time to look back later?
I would say it's a lot of the latter. The teams, the shuttle teams, at least the flight control teams, are very focused on going and flying the mission. We got hopefully 2 more, so we're fairly confident and can reflect later when we get out there. I'll also share with you, this is my 14th mission with Discovery. My first mission with Discovery was STS-31, which was a long time ago, obviously. But that was a flight we took Hubble up. And at the time, I'll go ahead and give you a war story because you guys sometimes like those things. At the time, are you scared? At the time, this was the first flight that we went and filled the OMS tanks. I was a consumables officer. I was in the back room. And it just, one of the many lessons the Space Shuttle program has shown us, just one of the gazillion, there's a gazillion of these lessons out there, but this is one of them. So we fill up the tanks all the way because we want to go as high as we possibly can, so we can leave Hubble up and as high in orbit, so we'll stay up there as long as it possibly can. So we all agreed, oh yeah, sure, we can fill up those OM tanks, no problem. So we have oxygen fuel on each side, an oxygen fuel tank on each side, left pod, right pod. And during Ascent, of course, the team is monitoring all the tank pressures. This is specific to the prop group, monitoring pressures, make sure the tanks are in good shape. Of course, in our training simulations, training guys teach us lots of things, one of which is how to deal with prop leaks. So they put in leaks in the tanks, in the system. So you see the pressures bleeding down. And then we run through our procedures, respond to that, do what we have to do to deal with that particular malfunction. On this particular flight, we filled up the tanks to full, so there's a little bit of helium at the very tip top of the tank, but mostly liquid, fuel on one side, ox on the other. And what we learned in real time is that the oxidizer tends to absorb helium. The fuel tank pressures all stayed very steady, up around 275. The ox tank pressures on both sides, and thankfully we had 2 sides to compare, but they started bleeding down. They dropped about 10 psi, if I remember right. It's a long time ago. But they dropped about 10 psi during launch. And at the time, we're going, oh, is this a leak, or is this just normal? Like I said, there were 2 tanks. They were both doing the same thing, so it made it a bit easier to call that not a leak and not respond to that. But it was just one of the many lessons that we learned throughout the history of Discovery and the Space Shuttle program on some of the unique challenges you get when you fly in space. And these lessons are all over the place. Every discipline's got them. Many of them occurred early in the program, but we're still learning lessons as we go. We got the boundary layer experiment I mentioned earlier. We're going to learn a great deal about how we're continuing to learn more about the dynamics of hypersonic flight and what that can do to you, the vehicle that you're flying at those velocities, and what it can mean to the crew on the inside. So we're excited that we get to learn all these things. Every new program that comes along, of course, has a huge bow wave of lessons to learn, and that's part of the challenge of a new program. Even before they get off the ground, there's all kinds of challenges and concerns and worries. But as you fly and you fly and you fly, you learn things, you get better and better. And it's just like cars today. We're all very familiar. Cars drive very well. We saw recently where a particular company is trying to get automated cars out on the roads and has been doing so. A lot of lessons to learn there, but cars are a pretty well-known thing, so you can design those systems, I'm not going to say easy, but at least easier. Flying in space, of course, has many unique challenges. This will be the 133rd flight of the Space Shuttle program, I believe, and every flight we learn things. So we're looking forward to this. Are we reflective? Somewhat, perhaps, but mostly focused on getting the mission accomplished and being sure that we bring the crew of Discovery home safely on November 12th.
Bill.
Bill Harwood, CBS. So two from me for Brian, I think. You mentioned focused on the mission. John talked a little bit earlier about layoffs at the Cape and system-wide. How has that affected mission control, and how do you see the, you mentioned focus. There are a lot of distractions out there and morale issues. How are you guys handling that in the MOCR?
Great question. We are focused on the mission, and what I'll tell you is that the team here in the Control Center and across the country on the Space Shuttle program is an extremely dedicated and professional team. We're all passionate about what we do. So yes, we know the end is coming, the end of the Space Shuttle program is coming, but we are passionate and absolutely dedicated to making sure that the final flights are just as safer actually, because we know a lot more about how to fly the thing, safer than the first few flights. So the folks are working really hard. There are distractions there, but we are professionals and we're dealing with those distractions just like you would deal with any other distractions.
And I know you're not lead flight director here. I noticed that 20 minutes ago the National Hurricane Center did Richard Jones, your Ascent flight director, the honor of naming the tropical storm after him. That looks like it's going to come over the Florida Peninsula here around countdown time. Have you guys even talked about this in terms of if those tracks actually play out, what some of your options are?
Hurricane Richard is coming? Yeah. Is that what you're saying? Actually, Rob showed us the plots of that just before we walked in there. I had not seen it. But I've lived on the Gulf Coast my entire life, and hurricanes come and you deal with them, just like we did with Ike, just like Florida has certainly had their share of hurricanes. And we'll monitor, see what happens. And if we got to roll back, I really hope that's not the case, or the folks at KSC have all their contingency plans in place to deal with if those ground tracks come towards them, what the timelines for those, I don't remember all the details, but they have all those plans in place and are ready to deal with it if we have to. I'll remind you, however, hurricane predictions are a challenge. It's a kind of an art, not a science, so as observing them over the Gulf Coast for the last 40 some odd years, wait and see. We'll see what we get. We'll be ready to deal with whatever Mother Nature wants to throw at us.
Yeah, I live there too, so I know what you mean. For Royce, really quick, you may have mentioned this, and I may have just missed it taking notes. What's the total up mass on PMN and ELC-4 in the Bay as you launch?
I don't want to quote the number right off the top of my head. It's on the order of 28,000 pounds. We can get the detail for you.
Thanks.
Gina.
Gina Sinceri, ABC News. Two questions. One, let's start, Brian, since you told us a little bit about your history with Discovery. Does this mission, since it's Discovery's last mission, have any poignancy for you?
Again, it just signifies the end of the Space Shuttle program is that much closer, and that reason, of course, we're all interested in making sure these flights all fly out very well and very safe. And as always, with every mission, the crew is our prime concern, making sure they come home safely, and that is what we're going to do. So I don't think it's any extra significance necessarily, but our job is to continue to be professional and focus on the mission, make sure those guys come home safely.
And Royce, does this mission complete the space station?
Well, we have as the next mission coming up, bringing the alpha magnetic spectrometer and the rest of the equipment that it has on it. So I would say we're almost complete. This mission does fly, as I said, in the last pressurized module that will be installed on the U.S. segment with the addition of the permanent multi-purpose module.
Eric, did you?
Yeah. Eric Berger with the Houston Chronicle, and I think the PhDs at the Hurricane Center may quibble with their craft being called an art rather than a science.
I don't know.
But for Brian, given that this is almost certainly the last flight of Discovery, is there anything different you're doing in terms of bringing the vehicle back, steps you don't have to take because you're not preparing the vehicle to fly again? or is everything going to be by the book as it has been with every other mission for Discovery?
It's the latter. Everything will be by the book as we've done the previous missions. And you bring up a good point. Years ago, in the mid-90s, we had these, between flights of each vehicle, we had a long list of maintenance items that folks at KSC would take care of. And we went and scrubbed those lists and said, well, shoot, what can we take care of while we're on orbit to save the time on the ground? And we came up with a long list of stuff, and we execute those every flight so that they don't have to turn around and do it on the ground. And we will continue to do that. We didn't go scrub those things out of our procedures. We're not doing anything different on this flight than we have in the previous, so we'll do all the same checkouts that we normally would do. All of that intended and designed to bring the crew home safely, just as we have done on the previous flights. Don't do anything different. Do it the same way you've been doing it, because we know that works pretty darn well.
Thank you.
All right, let's take a question from Mark, then we'll go to the other centers.
Hi, Mark Kirkman, Interspace News. This question's for Royce, and I'm not sure how much you can tell me, how much exposure you've had to it, but can you describe the Dragon Eye LiDAR system that you're bringing up? It's my understanding for SpaceX. Does that mean that it's not a program asset, it actually belongs to them? Can you tell me just an overview of how it works and what's envisioned to be gained from that?
And I'll defer that answer to Brian. I will tell you on the ISS side that we're collecting some GPS data for the rendezvous and undock that we'll provide for them for some post-mission analysis. But the equipment in the payload bay, I'll let Brian deal with.
So to answer your question, I think we flew it previously in STS-127. It's a box. I think of all these avionics things as that's a box, there's a box. It's a box that sits in the payload bay next to the orbiter docking system. The crew flips a switch to turn it on flight day 3, and they flip a switch to turn it off after we get docked, and we'll turn it on and off, same for undocking. It's a LiDAR, it's a laser, it's collecting ranging information. It's got a GPS on board, this particular one, and they're collecting data for GPS as well, which is what they will use post-flight to compare to the space station GPS. It is purely owned by SpaceX, and we have very little interface with it other than that switch throw. We turn it on, we turn it off. If there's issues, problems, we won't know in real time necessarily, and nor will we troubleshoot any of that.
Again, I don't know what makes it happen with Oregon, but I do know you're leaving one of the handhelds behind. What's the reasoning for that?
ATV or HTV? HTV. We were asked to leave one of our handheld lasers behind, which is a handheld little device they use to shoot at an object and get a range and a range rate over time, of course. We were asked to go ahead and leave one of those on board as a backup to a backup probably for when the HTV comes flying in. The crew will have that if they want to pull it out and use it. And I think we did a similar thing after STS-128. We left one up there and brought it back after that.
Okay, let's go around to the other centers. We'll come back here to JSC for follow-ups and down to Discovery's launch site at the Kennedy Space Center.
This is Marcia Dunn of the Associated Press. For Brian, a couple questions to start with you. Have you had a chance to reflect with your father perhaps the parallels or similarities or not between the end of the shuttle program and the end of Apollo? I was wondering if you could share a little bit of that, please.
That's a good question there. Probably not in those specific terms. Of course, my dad and I talk a lot. Dad was involved in the program in the early days, and he was also shuttle program manager. I think it was for STS-2 and a few flights thereafter. So he has certainly been involved in the early days of the shuttle, the latter days of the Apollo, and he's still paying attention. Obviously, he's still in the neighborhood. He still comes and visits. I saw him in the cafeteria yesterday. He was up here doing some other things. So Dad and I often get a chance to talk about various things, and I got to say our biggest concern, of course, is the future of manned spaceflight. He got involved in spaceflight because he thought it was good for the country, good for the world, and I got to say that I have the same motivations. We think what we do is important, the science we collect, the lessons we learned, and just the exploration benefit of having mankind doing these things is a must, in my opinion. So he got involved for those reasons. I am involved for those as well. And ending the shuttle program with the gap coming up and some of the other things going on, we are concerned that what we've invested our lives in, we want to make sure that it continues to go well. So there's lots of other opportunities out there, of course, and we'll go explore those and see how those happen. And as far as the end of the Apollo program, we haven't specifically talked about that. We've just talked about what's coming next, and we're looking forward to what that is and hoping that it's all going to turn out well.
Thank you. And I'm wondering, Does Mission Control or the crew plan any special commemorations during the flight because this is Discovery's last flight, or any special payloads or that are going up specifically to mark the end of Discovery's flying time?
Yes, I think you'll see, similar to an STS-132, when that crew thought that could have been the last, it was the last planned flight of Atlantis at the time, they did a little tribute, if you will, a video where each of the crew said a few words. I expect we'll see a similar thing on this flight, probably flight day 11 or flight day 10 after undocking. They'll share with us some of their thoughts and reflections, so something to look forward to.
And for Mr. Renfrew, I know we have a Robonaut briefing coming up, but from your perspective, once the Robonaut container goes over to the space station, is it opened up at all during the shuttle visit, or when does it get put off to in terms of whatever happens to Robonaut from once it gets on board?
Yes, actually not any time during the mission do we intend to deploy the Robonaut. The stand and the upper torso of the Robonaut stays in the permanent multipurpose module all the way through the dock time frame. And then during the increment ops, after 133 is gone, we'll get it out, assemble the two components together, and start doing some investigations into that science program on board ISS. I believe the destination location for that is in the U.S. lab.
Do you have a timeline for that, even ever so vague? And are you personally excited about the prospects of what Robonaut has to offer?
And I don't have a timeline. I have to tell you, I've been absolutely focused on this mission 133, and because I'm not deploying Robonaut, I haven't tracked it more than the fact that I know where it is in the PMM, and I know I don't have to get it out. It's exciting. It really is. Brian's been telling war stories all along here, and I have a young daughter. I like to tell her that all of the stuff that I used to watch when I was a kid growing up, as far as science fiction and all the books I used to read, are apparently coming to life here. So it's a very exciting demonstration technology that we're going to get on board ISS. And I know those guys have been working for years over in one of the buildings here in JSC. I've wandered through that for years now and saw the Robonaut get assembled, and to finally actually see it get launched and start using it on ISS and learn how we're actually going to operate it and how we can fold it into our normal operations is a very exciting activity. And as you said, there is a detailed Robonaut briefing by the experts who can give you all of those details a little bit later this afternoon.
Hi, it's James Dean from Florida Today. I have 4 questions that I think may all be for Royce. First, if I recall correctly, the installation of that power extension cable was something that was initially planned during the pump module R&R and was considered a prerequisite to installing the PMM. And I was just wondering if there was some problem on EVA-1 getting that installed. I don't know how simple a task that is, but if there was some problem, would that impact your ability to install the PMM the next day?
We had originally planned to install, it's the J612 cable that I mentioned in my briefing that we're talking about here. We had originally flown that uphill on, I want to say, 37 progress. It came uphill, so we would have it to be able to do the stage EVAs that we had scheduled, stage EVAs 15 and 16. And we were going to go install that cable as part of those 2 stage EVAs. As we were going through the preparation to do those stage EVAs, however, we had the failure of the Loop A pump module. So the installation of that cable, while it was a high priority task to get ready to go fly 133, was not as high a priority task as actually to R&R the Loop A pump module so we could restore nominal external thermal control system cooling. So during the 3 EVAs that Doug and Tracy did to go change out the pump module, we simply ran out of time on those EVAs doing the higher priority tasks. So we absorbed that activity on 133, and that's, as I said in my brief EVA overview, that's the very first task that we do on EVA-1 before we get into any of the other tasks on the EVA.
Okay, I was also wondering why you couldn't bring home the pump module on Discovery or even the next flight. I assume it requires a specific carrier, like maybe an ELC or ESP or something. If that's the case, how will you get it home if the flight schedule allows you to do so?
Well, your musings there are perfectly correct. We need a particular carrier to bring that home, whose name escapes me at the moment, actually. But a particular carrier in the Payload Bay, and at the time the pump module stuff all came up there in August and September. We took a quick look at it and just knew at that point there's no way to rearrange the Payload Bay to fit that carrier on Discovery with the other items that we had in the Payload Bay. Looking ahead to 134 is a similar answer. The AMS is sitting back there, and there's not room to put that carrier. So for 135, they're shuffling things since it's far enough away where we can go and figure out how to put that carrier in the Payload Bay. So it's expected that for 135, assuming that flight is approved and authorized and appropriated and all those good things, and if we get to go fly that flight, that we'll be able to bring it home on that particular flight with the right carrier in the Payload Bay.
Okay. Royce, normally with an MPLM mission, you have a hectic schedule of transfer of stuff, in and out of that module. Obviously, with it staying up there now, assuming that's not as much of a factor, I just wondered if you could describe kind of the transfer activity, how busy that will be on this mission, what is getting transferred, if anything. I know you mentioned some packing materials or something, but how that will compare to MPLM missions we've seen in the past.
Sure. So nominal MPLM mission, I think you described that accurately. It's a hectic schedule to get all of the new hardware out of the MPLM, stow it somewhere in ISS, and then get all the old hardware, the stuff we want to bring back home, stowed back in the MPLM during the dock phase so we could put that module back in the payload bay and bring it home. I think the answer to your question is that we still have a very hectic schedule doing a lot of other activities. They just don't happen to be transfer because we don't have to empty the module. We have multiple R&R activities, in-flight maintenance activities that we're doing. We have the 2 EVAs that we're going to go execute and 2 big payload installations. So it's a very busy mission. It's just not busy in the fact that we're transferring cargo back and forth. All told, we have about 30 hours of mid-deck transfer on the mission. The CO2 absorbent bed coming up in the payload bay, coming up in the mid-deck that we're going to replace for the carbon dioxide removal assembly, bring the old bed home. We're also bringing up that water on-off valve I mentioned that goes in the Columbus module. Another big item that we're bringing home in Discovery's mid-deck is the hydrogen dome that comes out of our oxygen generating system that failed previously. We replaced that with a spare. We're bringing that failed hydrogen dome home in Discovery's mid-deck, but the packing for that actually comes uphill inside the permanent multipurpose module. So that's what I was referring to before. We'll go get that packing out so we can get that H2 dome on the ground.
Okay, thanks. And finally, Royce, just thinking about the debris shielding for the PMM. I was thinking about how you rely to some extent on the shuttle fly-arounds to get an assessment of the station's condition after each mission, and as I understand that helps you to really detail where you may have things like debris strikes and any kind of issues around the station. I was just wondering if, looking forward, if you could speak at all to, how you'll be impacted without shuttle fly-arounds to help. How well will you be able to monitor the station's exterior condition and potential debris strikes?
Sure, and that's, we still have 134 coming up in the first part of next year, and then hopefully a 135 mission also next year that'll be able to help us at least do a baseline for the ISS config, in particular for the permanent multipurpose module that, again, we're going to install on this mission. We do get tremendous benefit out of the orbiter fly-around because we've done it for so many missions, and we can go back and compare the orbiter fly-around from mission X to mission Y to see if there's a ding on the vehicle from micrometeor or whatever. However, we also do have a tremendous amount of camera assets on board ISS, including the mobile assets that are from the space station remote manipulator and from the GEM RMS as well. So we do a lot of surveys during stage ops where we're looking at in particular things. So yes, we'll we have learned a lot. Brian talked a lot about what we've learned in doing human spaceflight. We've learned a lot about how a structure that big behaves in space by looking at the data that we gather from the orbiter fly-arounds. But we'll continue to learn that after the orbiter stops flying by using the assets that we have on board ISS.
Okay, we'll go to NASA headquarters for questions before coming back here for follow-ups.
Hi, this is Denise Chow from Space.com. Just a question about the PMM. I'm wondering if you could outline the interior changes, the most significant changes you made to the interior of the module, and specifically what type of hardware you eliminated to reduce the weight.
Sure. One of the big things that we took out there was the internal thermal control system. Most of the ISS modules that have an active thermal control system, we flow water through various loops. The water on-off valve that Scott's going to change out for us in Columbus is part of that system. In the permanent multi-purpose module, we don't have an active thermal control system. We have shell heaters that are strung out around there to keep it warm, but we're not actually flowing any water through the system to be able to cool off any racks. So we took that equipment out. That was one of the big weight savings that we took out of the module in order to be able to get additional payload in it. We also, as I said, modified some of the avionics racks, the avionics fold-down containers inside the PMM to allow the crew to be able to fold down the hatches to get to those avionics boxes without having to disconnect a bunch of cabling. It's pretty easy for the guys at the Cape to do that when we have it on the ground because the module's powered off and you can just disconnect all that stuff. For a module that we want to presumably keep up and happy while we're doing some activities, we don't want to have to power it down. So we extended some of those cables to make those IFM tasks a little bit easier. We've also gone through and taken out the wiring that would be necessary for an ATU, an audio terminal unit. There's not one in the module, and there's also not a utility outlet port in the module where the crew would plug in a laptop if they needed one. Again, with the idea here that we're not doing science and we're not doing payload activities in this module. It's really just for putting in equipment that we don't need, and we don't spend a whole lot of time in there.
Okay, we're back here at JSC for final follow-ups in the back.
Philip Sloss with NASAspaceflight.com. Question for Brian. On the boundary layer DTO, I understand that you want to avoid doing a role reversal during the period where you might trip the boundary layer. Is that going to have any operational limitations in terms of, I think I also saw that there might be some cross-range limitations for entry?
Right. So what you're alluding to there is we have identified when we expect the boundary layer transition to occur. It's around Mach 18, Mach 19. We've also identified which cross ranges would cause a role reversal to occur, because your cross range predetermines when your role reversals will occur. So we're going to try to avoid those if we can. We may consider doing orbit adjust burns to help that. Tony Sacacci and entry team will go through all those calculations once we get undocked to see what's available. Our number one priority, of course, is to land at KSE, to land safely, and we have a list of other things we do consider for those orbit adjust questions. So if we can accommodate it and still accommodate all the other things, we may target an orbit adjust type burn to improve that first opportunity KSE's cross range for this experiment. But then, as you know, weather may be a problem. We may not land on that opportunity, and we kind of take what we get on the subsequent opportunities. So again, Tony and the team will go through all those discussions and determine if it makes sense, given everything else that's going on, to do an orbit adjust type thing to try and optimize that particular cross range for the first deorbit opportunity, and decide whether or not to do it.
That's it.
Okay,
Thanks.
Any other follow-ups here? Okay, no other follow-ups. So our programming note coming up on NASA television, our pre-flight briefings will continue later today with the spacewalk overview briefing featuring lead spacewalk officer Art Thomason, followed by the Robonaut 2 briefing with Rob Ambrose providing all the details of the humanoid that will reside aboard the International Space Station. Following that, Discovery 6 astronauts will be here for the traditional crew news conference. So stay tuned throughout the day on NASA TV for all of those briefings. You can follow Space Shuttle and Space Station activities on our website at www.nasa.gov. With that, we'll look forward to the rest of today's briefings. Thanks a lot for coming.
Good afternoon and welcome back again to the STS-133 pre-flight briefings. We're here now to focus on one of the items being brought up by Discovery to the International Space Station inside the permanent multi-purpose module, Robonaut 2, soon to be the first dexterous humanoid robot to visit space. Here to tell us about it, we have Rob Ambrose, the acting chief of the Automation, Simulation, and Robotics Division here in the Engineering Department at Johnson Space Center. We'll start with an overview and then take questions from the audience. Rob?
Thank you, Brandy. I'm here talking to you today about a project that we've been working on for about 15 years. So it's really the culmination of many people's effort, a terrific group of engineers that we call the Robonauts. We might think of a robot like Robonaut as the machine, but we really think of the people behind the robots as the real Robonauts. In the room today, we've got one of the latest units that we've built. It's Robonaut 2A, the first in the Robonaut 2 series. If you can take a look at it, if we can cut over to show you the robot. It's in the tuck and ready for launch position. R2B is the one that's currently packed and ready for launch in the same posture, preparing to go visit the International Space Station on board STS-133. I'm going to show you today some of the history that got us to this point and talk to you about some of the challenges that the team met and the future for what the Robonaut system will deliver for us. In addition to all the engineers that are behind the Robonaut team, robotics is a growing field. It's a potential future market for our country and the world. And there are a number of communities out there that are also looking to this launch as validation of the decades of research that have made things like Robonaut possible. So in a sense, while it might be just a single step for this robot, it's really a giant leap forward for mankind. The challenge that we accepted when we started the Robonaut project was to build something capable of doing dexterous, human-like work. And here at the Johnson Space Center, where we're very focused on human missions, the idea was that that robot would be doing that work side by side with astronauts. So from the very beginning, the idea was that the robot had to be capable enough, strong enough to do work, but at the same time be safe and trusted to do that work right next to humans. If you move to the second slide, you'll see the history of, well, so there's our vision, our history for the Robonaut 1 project going back to the first integrated products in 1998. A whole series of developments building the Robonaut 1A system. It started out as just a couple subsystems, an arm and a hand. By '99, we'd put the arm and the hand together with a head. And for the first time, we experienced dexterous telepresence, where we could really kind of step into this robot and reach out and interact with objects, and in particular EVA tools. And at that point, we realized we really had something special, that this capability was possible and that it was within our grasp. The Robonaut 1A system evolved over a couple years. We added a second limb. We went upright with a torso and formed what we think of as an upper body for a Robonaut system. Then we commissioned the Robonaut 1B unit, where 1A had a lot of electronics in a rack. Off to the side, 1B's electronics were all integrated in its torso. And that opened up a whole new series of opportunities for making the robot portable, able to move around, not just requiring that work be brought to it, but that it could go to the work and do the work where it sat. We tried a number of lower bodies. There's a picture there of a Robonaut 1B with a leg, which would be appropriate for climbing on the outside of the space station, or for on the inside for that matter, plugging into work intersite fixtures. We also tried it on a Segway, and then there's a photo there of a four-wheel base we built called Centaur, which we named based on the fact that it kind of looked like the mythological creature, 4 wheels, not 4 legs, but with the upper body of a human. We took that out to the field and tested it working with natural objects like rocks and geological samples. We learned a lot of things about the upper body, the dexterity, the component technologies, system level redundancy, and made major steps forward in the software. We were partnered with DARPA, the Defense Advanced Research Projects Agency, and teamed with a number of tremendous research partners across the country: USC, MIT, University of Massachusetts, Vanderbilt, Rice, and other universities were all brought in and have contributed in many ways to the Robonaut software. But at the end of this series, we had a number of new ideas, and you could only incrementally upgrade a robot so much. We had some ideas for what Robonaut 2 would be, and we went looking for some external funding. If you could go to the next slide. We found a terrific partner in General Motors. They shared our vision for a robot that could do work, real work, and do it safely next to people. Kind of at the core of that idea is that we're not replacing people. It doesn't make any sense to build a robot that can safely work around people if there are going to be no people. It's really predicated on the idea that there will be people working with the robot. They liked that idea. They saw that as a part of their future of combining humans and robots working together, and they agreed to partner with us on the development of the Robonaut 2 series. To date, we've built 2 units. R2A is the one here in the room with us today, and R2B is the one that is packed and ready for launch on STS-133. We went through a similar build-up where we built the Robonaut 2 limb first, the right arm on R2A, and then we built the second limb and the torso, and then moved on to the second unit, R2B. When we were given the challenge to take a Robonaut 2 to station, we selected R2B as the more recent one, and initiated a whole series of tests and then redesign to qualify the R2B system for flight. At the bottom of that slide is a photo of R2, one of the R2 units, in a test chamber out at the White Sands test facility. This was just one of the many tests that the Robonaut system had to go through and pass before being allowed and be certified for use on the space station. In that particular test, the robot was put literally in an oven and baked at 120 degrees for about 4 or 5 days. And at the end of that, the air was extracted from the chamber and sniffed by a computer nose that found very little off-gassing, and the robot passed. It's very important when you put something like a Robonaut in an IV environment that you not off-gas, emit chemicals off of the system and pollute the environment. It turns out the Robonaut 2s are pretty clean. The Robonaut went through a whole series of additional tests, and it's been a great last 6 months or so getting it certified. Go to the next slide, please. Let me tell you a bit about the arm. Superficially, it's very smooth and padded. There are no sharps or hard points that could hurt a person. But that's really just the beginning of making a robot safe. At the core, in the muscles of every joint, are springs that make the system compliant. So if you go push on it, it feels soft. So if the robot's minding its own business and just basically turned off, and an astronaut were to bump into it, it would give a little, and it would not injure the astronaut. That's using a series of springs that we developed with sensors capturing the deflection of the springs in a concept called series elastic actuation. We've also developed a way to coordinate those springs, not just through an entire limb, but with 2 limbs, reaching out and grasping objects in common. Most robots can't do that safely because they're very stiff, and a very slight position error would produce large forces, and the 2 arms would damage themselves. Because these robots are fundamentally soft, we are able to program them to work together with multiple arms, and in fact work with humans holding the same object. So superficially it's soft, padded, and safe. Mechanically it is soft as well with springs. But deeper than that, it has 3 levels of sensing sensors, electrical sensors, and software that can, in each of the 3 levels, identify forces that are being felt by the robot, decide if those forces are safe or not, and stop the robot. That 3 levels of safety was essential in convincing our payload safety review panel that this robot would be safe to work adjacent to astronauts inside the space station. Each of those 3 levels has a separate sensor pack, separate cable harness going back to a separate process running, monitoring those forces. And if there's ever a problem, the robot can either just stop and wait for the problem to go away or completely turn itself off. It's programmable so we can have different levels or thresholds at which it will either pause or completely turn off. That is at the core of every motion that the Robonaut system makes, and it gives us confidence that the robot will be safe working around us. I'm going to now play 2 videos, well, a combination of 2 clips. Go to the first video sequence that shows this paradox. We want to have a robot that's both strong enough to do work, and at the same time safe enough to do it right next to us. So the first part of this shows it handling a dumbbell. That's a 20-pound dumbbell. You can relate to what that would feel like if you were to reach out and pick it up. Unlike people which tend to cheat, this robot will really do what the physical trainers tell you to do, which is to do the bicep curls nice and slow. So as the robot's doing it, because of your empathy and the monkey see, monkey do ability of the human, you can almost feel what that robot is feeling. You know what that would feel like curling that weight, and that's because that's the way humans work. We look at other humans and we can kind of know what it would feel like if we were them. That applies to this robot. It is so human-like. You have a good idea of what the forces are that are involved. You can kind of feel the burn, right, as it's doing that exercise. Humans have greater peak strength and peak speed than a Robonaut 2. You know, for a robot to be your assistant, you really don't want it to move too fast. But a Robonaut has more endurance than a human. While it might not have the same peak strength or peak velocity, it can do things much longer. And that's what you would really want in an assistant. If you asked the robot to hold something and then you were going to work on it for a while, the robot would not complain if you asked it to hold it for 30 minutes in the same position. That is what you'd want in a good assistant. And unlike some people, it will put things back when it's done. Another very useful thing in having an assistant. When you're done with an object, it can put it back for you. So it's strong. You will not see most of the humanoids out there handling 20-pound dumbbells. Most of them don't even really have fingers. They do a lot of dancing, and we're fine with that. We could probably program a Robonaut to do dancing, but we're pretty sure no matter what dance move we would give it, it would always do the robot. For us, it's more about doing work, and that's why we really focused on the upper body. So here it's doing a sequence. It's running through some open space motion. And now Dr. Ron Diffler is going to step into its workspace. We call this the Hit Ron demo. And you see the robot stopped. It paused. It detected that Ron had gotten in the way. And then when he let it go, it continued on with its sequence. While it's pausing, it's applying a very light force. It's trying to catch up. And when it does, it goes back to the motions that it's programmed to do. So this is running at the core of the robot every single time it moves. If a person steps in the way and interferes with it, nothing dangerous is going to happen. The robot will just pause. And if you hit it really hard, it'll stop completely and turn itself off. So we have those 2 levels of safety that are always running whenever a Robonaut is in motion working with our astronauts. So move on to the next slide, please. I'll tell you a little bit about the hands. Within each finger, we've got tendons, and we have force control. We're able to sense tendon forces and map that to finger forces. We also have load cells on every phalange, every finger bone, so we can measure fingertip contact forces. We can also resolve the direction of those contacts, so we can understand and let the robot understand that it's made contact with an object, and even use those fingers kind of like sensors to map out the shape of an object. You'll see how that's important in a minute. We've mapped those tendons and tip force sensors into whole finger control modes that allow the robot to be given different things like a soft grasp or a hard grasp, power grasp, and lots of different shapes of grasps that humans just really take for granted. This hand is a mechanical marvel. It's a mechatronic marvel because it's integrated with electronics as well. It has some things that humans just take for granted but that you don't see in a lot of robot hands. It actually has palms. Most robot hands only have grippers to grab things between fingers. They don't envelop objects and bring them into a palm. The second thing that this robot has that's unusual is a soft covering. We take that for granted. As humans, we have skin, and sometimes we put other layers on called gloves. If you look at most robot hands, they're hard steel fingers. You would not ever want them to grab an object and then have an astronaut grab that object later. If it was an object that was made out of aluminum or steel, those hard fingers might leave a burr or a nick on that object that could later cut the astronaut's glove. What we want is to have a robot that does not cause nicks and burrs in the environment and will be safe to handle the same objects that we'll ask astronauts to handle. The skin is also really important for friction. We can put different kinds of materials in and give the robot's skin, palmar surfaces of the fingers, different levels of, different coefficients of friction to allow it to grasp objects more completely. And also a little cushioning, give some give, and allows the robot to have both a very delicate, fine force resolution, yet still be tough enough to really get a white-knuckle grasp on an object. I'm going to show you a couple video clips here that demonstrate how we take advantage of that. So play the next video, please. So this shows the robot hand kind of groping an object. It's a flexible material that's got a bump in it. The robot is basically scanning the object, using its sensors to map out the 3D shape of that object. It wouldn't need to do this every time, but once it's learned the feel of the object, it could apply that. So it grabs the object, it immediately knows where it is, and can now put its thumb in that divot. By having first familiarized itself with the object, it's able to now do that automatically. When it just first makes contact, to immediately know where it is and slide its thumb into position. As far as we know, this is the first robot that has that capability. Okay, next slide, please. Oh, okay. Oh, well, that's fine. We can play this video. So now, we're now going to talk about the future for the Robonaut system. This is the very recent past. The Robonaut 2B system was processed at the Kennedy Space Center, being prepared to be packed in the MPLM. So this is a time-lapse video showing the technicians, both Robonaut engineers and the Kennedy workforce, integrating the robot in its packing container that's then loaded inside yet another packing container for launch into space. And you can imagine after 15 years working on the project how excited the engineers were to participate in getting to load up this robot and prepare it for a ride into space. It's in that same tucked position like the R2A is here in the room today. The station team built a terrific protective cage that packs the robot in foam, and then that box itself, as you'll see, is encapsulated in another layer of foam. And we didn't skimp on the screws. Now there's actually a couple other robots involved here. That one's a crane. People don't normally think of it as a robot. But the next one you'll see, most people would probably call it a robot. It's a very large machine that's going to reach out and grab this box. So there the Robonaut box is being encapsulated in yet another layer of foam. And And now this enormous robot arm is going to pick up the little robot and pack it inside the MPLM. Okay. So you can imagine trying to reach into a canister like this would really ruin your back, but that giant robot arm has no problem. If you've ever tried to load a pickup truck, you'd know why you want this robot. And that's as we left it, ready for launch. I'd like to show the last slide, which shows some potential future applications. Obviously, we're very excited to get R2B sent to station. We've been working on some other lower bodies that are of interest for future applications. We'd like to add legs to the R2B system so that it could climb around on the inside of the space station. Again, we don't want to just have to bring work to it. We would like, once we've shown the robot's ability to do work, to free it up to climb around on the inside of the station and go to where the action is, solving problems for the crew. We've identified a number of tasks that we think are appropriate for the robot. It's being shipped with a task board. That's basically a test apparatus that has a lot of different interfaces on it. It has switches and latches and valves and triggers and various EVA and IVA interfaces that the astronauts use on a daily basis in space. And we're going to practice using the Robonaut 2 system on each of those interfaces. We have a similar system here on the ground, and we will, of course, try everything first on a ground robot. But the questions remain as to how the robot will work in zero gravity. Will all those interfaces work the same when there's no gravity load on the robot? And we'll compare the gravity results with the zero gravity results from the robot in space. We're also looking at some surface applications. We've got a new wheeled base that we've developed called Centaur 2, an upgrade to the ride we built for the Robonaut 1 series. The Centaur 2 was recently taken out to Desert Rats, one of our analog field test programs, where I was given a shakeout cruise. And that base, shown there in the center, really proved its mettle. It's going to be a fantastic little rover for the Robonaut to ride on, and might be the precursor robot of the future, able to go out ahead of astronauts and explore worlds before the humans get there, assist astronauts when they're there, and or maybe be left behind as a caretaker. We're also looking at legs and other wheeled bases that might be appropriate. And throughout the history of the Robonaut team, considering lots of different lower body options has been our philosophy. It's allowed us to adapt the system to different kind of worlds, different gravity levels, and find the right mobility for the application, but at the same time allow us to stay focused on the upper body, the part of the Robonaut that really does the work, because that's what the Robonaut program is all about. We have one last video. It's kind of a vision of the future. We would like to take the Robonaut 2 system outside once we add legs to the system so that it can climb. We would like to go outside with the Robonaut and help the crew with EVA tasks, just like it'll be helping with IVA tasks in this coming year. If we could play that last video. So pretty amazing rock climbing, right? Zero-G rock climbing, but you'd still like to have a leg or some kind of stabilizing appendage to free the hands to do work. Because we've certified it for indoor work with toxicity and flammability certifications, we've really built an indoor-outdoor robot. So it might just go in and out through the airlock like the astronauts do. But unlike the astronauts, it could be left out indefinitely and available for emergencies like patching leaks or other emergencies that have to be dealt with immediately while waiting for astronauts to go EVA and come out to help. So that's been the vision for the Robonaut system, working safely with humans for over 15 years. It's a dream come true to get to launch one. I can't tell you how excited we are. All of the Robonaut engineers have looked forward to this day for many years, and I applaud them for their patience and persistence and all the hard work that's gone into making this possible. At this point, I think we're ready for questions.
Okay, we'll start here with questions here at the Johnson Space Center, then take questions at other centers.
Hi, Robert Perlman with CollectSpace.com with a couple of questions. First, given how packed up it is and multiple layers of foam and screws and such, how long will it take the astronauts to unpack?
We think a couple hours should unpack the system. There'll be a lot of screws they have to keep track of, but it's not that hard to unpack it.
And with the example that was given on the hit and dawn, I guess.
With the what?
Hit dawn example.
Hit Ron, actually.
Ron, okay, Ron.
Right?
Ron was on Earth with gravity anchoring him to the ground. If an astronaut was free-floating and an arm were to come in place, does the small pressure that you mentioned, does that have enough force to push the astronaut back?
So this is one of the things that we're going to be experimenting with. On Earth, we've set the thresholds where it will pause at, just a couple pounds, and then thresholds for it completely safing itself a little deeper than that. But those forces are kind of biased by all the gravity loads that the robot feels. When we get into zero G, all the gravity loads go away. So if it feels a contact, it feels loads that's really contact. So we should be able to dial down those thresholds to an even finer level. So we can't simulate that on Earth. We don't really have a zero G chamber. So it's part of the reason we have to do this in space is to experimentally lower those thresholds and make it finer and finer to see how low we can go. How light of a force could the robot detect and still pause? That's one of our experimental objectives. On Earth, we're on the order of like 1 or 2 pounds to move it around once it's paused.
Mark Carreau for Aviation Week.
Hey, Mark.
Hi. Can you tell us what the plan is for unpacking Robonaut in terms of time frame? Will it happen on this mission or some weeks away? And what do you sort of anticipate being the first series of activities that you would do as far as testing or operating or shaking down or however?
Well, the crew are busy. We're scheduling when it will be unpacked. It'll be long after the shuttle has left. We're hoping for a good Christmas present around Christmas time, maybe early January. We have a whole series of tests that we would like to do. The first is just a power-up test and watch the levels and make sure that everything came up as we expected. And then a whole series of kind of incrementally turning on more and more parts of the robot and verifying that the robot is healthy and that the current levels are the same as they were measured at Kennedy right before it was packed. So a whole series of those kind of checkouts. The robot is designed with a base stanchion pedestal, so it could be set up pretty quickly, and the astronauts can set it up or leave it up at their disposal. Over this year, we've got a whole series of task board experiments. Once we've checked out the robot, we'll kind of work our way across the task board from some of the simpler interfaces to the more progressively complicated ones, finishing handling flexible fabrics, something that robots really don't do well, but that Robonaut is really well designed to handle. So we'll kind of progress our way across the task board. Then we've got a couple tasks that we've been thinking of that we would like to mock up on that task board. And here we'll probably want to take advantage of equipment that's already on station and have the astronauts bring it to the task board. 2 tasks that have been identified are both housekeeping tasks. For 20 years, I've asked people, if you had a robot, what would you do with it? And very consistently, I've asked that question, and of kids, I get 2 answers. They first say, I would like it to do my homework, and then the second answer is, and then clean their room. When I ask adults, they always say cleaning, and then they usually mention either kitchen or bathroom. Very consistently, I've asked that question, if you had a robot, what would you have it do, for over 20 years. And House cleaning is at the top of the list. So there are two that we're looking at. The astronauts have to wipe down the handrails inside the space station with some wet wipes once a week, just for hygiene reasons, not to pass germs and develop biofilms. What a great job for the robot. Where the astronauts might be able to do it in a Saturday morning, wouldn't it be great if the robot was just always doing that, working its way around the station, always kind of cleaning? Another is vacuuming the air filters. All the electronics racks have these air filters. So as they're bringing air through the racks to cool it, the filters capture particulates and keep it from going inside the electronics. The crew have to go around and pull out these air filters, and then with a separate vacuum cleaner, vacuum out each of those air filters. Another very tedious task. I'd much rather give the crew their Saturday mornings back. If we could let the robot do those housekeeping tasks, what a great thing to give the crew back. And I think it fits with terrestrial models for what robots should do helping people. We're looking for more tasks, though, and it might be the crew are our best source of ideas. I'd like to say that the STS-133 crew has been terrific in embracing Robonaut on this ride to station, and we've been working with some of the astronauts that will be working with it on station. They've got a great attitude, thinking about what the robot could do, embracing this new idea, and being very creative about applying the technology to future missions. I'm really looking to them to come up with the next tasks for what the robot could do. They'll be living with it. They'll have a lot of time with the robot, and I'm really excited about what they will come up with as experimenters.
Thanks. Could you just talk about turning it on? Do you turn it on once and leave it on forever, or do you turn him on, and if you do, how long does it take? And if you turn him off, how long does that take?
They come up pretty quickly. There's a console that looks remarkably like your laptop that is set up that is used to operate the robot. It comes up in just a matter of minutes, and it goes down much quickly than that. In an emergency, it shuts itself off instantly, but normally it takes a couple minutes to turn it off and bring its power levels down. We will likely bring it up and use it for a session and then turn it off. One of the things that we've always done with our robots is we've had an emergency stop switch that we've used to just be safe. Because of the 3 levels of safety software, we are not going to need to use that switch. So we're not going to waste an astronaut having to float there with their thumb on a button the whole time. We really trust the robot to do the right thing and to be safe. That said, the astronauts will be able to operate the robot, or conduct experiments with the robot, or just turn it on and let people in ground control run those experiments.
Eric Berger with the Houston Chronicle. So in a year or two, as you sort of get into shake out the robot and get to the experimental phase, what constitutes a mission success for you?
So we've kind of laid out an evolution where the robot will first demonstrate its ability to do tasks with its hands in 0G. For us, that will be mission success. But for the robot to really be useful, it will have to be mobile so it can go around and do work. So from a technology standpoint, demonstrating the ability to handle all these interfaces in 0G is really our engineering objective. From a practical standpoint, having the robot really pay its own way, it needs to be mobile so that it can climb around station and do work wherever the work is found. So the evolution is this year it'll be mounted fixed on its pedestal. Next year we're looking to send up legs so that it could be upgraded to go mobile. And we would like the year after that to send up a torso upgrade, a computer upgrade in its chest to allow it to go EVA, allow it to go outside into the thermal vacuum environment of space. So that's the evolution. From a engineering standpoint, the 0G manipulation is really our primary objective.
And just a quick follow-up, could the legs and the torso, I mean, that's a pretty sizable thing, go up on a Progress, or how would you get that to
Yeah, there are a
station?
lot of options that we've explored. They would be smaller pieces than the whole robot, smaller packages. We've looked at progress HTV, ATV, and maybe future commercial options for launching Robonaut parts, upgrade parts in the future.
Thank you. Hi, Greg Dobbs with HDNet Television.
Hi, Greg.
2 questions, please. Number 1, the long-term task goals. You talked about what it can do, and those are really tests to utilize it in the station. But deeper into space, you said generally maybe it will enter worlds that are unexplored before man goes in. Can you be more elaborate about your long-term goals and long-term capabilities?
So for robots that are designed to work with humans, there are really 3 phases of exploration. The first phase is where the robots are out ahead of the humans. Then the second phase is while the humans are at the same site, the robots working with humans. Typically, those phases of a mission would be short, maybe weeks or months. And then either in between human crews, going back to the same site, or where the humans never return to that site. In either case, the robot would be left behind as a caretaker to run longer-term experiments, maybe set up by the crew and then tended by the robot. So those are really the 3 phases where a robot could help humans as precursors to human missions, during the human phase of the mission, and then following human phases as caretakers or experiment tenders. This robot with different lower bodies is applicable to many destinations. We're obviously starting with in space, where it's going to be working in a zero-G environment, zero-gravity environment. We've been testing them to date in a 1G Earth gravity environment. So basically any planet with gravity up to Earth's, we think we can handle. So that would include Mars and the Moon, and certainly any asteroid. The robot is obviously strong enough to handle objects in 1G and would be quite capable in 0G, the microgravity of an asteroid on the lunar surface or on the Martian surface. So those destinations are ideal for this robot based on the way it's been designed. In each case, we would probably want a different lower body. So again, we're more focused on the upper body, the part that does work, and we're looking at different lower body options that can be used to customize it to the specific destination.
And the question about power, it's not going to have scrambled eggs every morning. What will power it? What will recharge it? Is it exotic or is it fairly conventional?
Well, at this point, it's really simple. It has no stomach. It's amazing what a human can do on one Hershey candy bar, right? It's a lot of energy in that Hershey candy bar. This robot has no battery or storage, so it's plugged in. Its backpack is an adapter that adapts from the station flavor of power to all the different voltages and currents that the robot needs inside. To go free climbing, we need to swap the backpack out with a new backpack that would have a battery or some other energy source that could then go recharge itself. That would also be the ideal backpack for going outside as well, where it would be able to work for some period of time unplugged and then get back in time to plug itself in and recharge. If it's plugged into a rover, it may need no backpack at all. If the rover is designed to provide just the right flavor of power to the upper body, it may need no backpack and be able to plug right into the rover's power supply.
Hi, Mark Kirkman, Interspace News. I actually have a million questions, but I think Brandy's only going to have a couple. Where on station will R2B be located at?
In the U.S. lab.
In the U.S. lab. And I assume you've tested in the VR lab the ability. Does he have the ability to get anywhere on the station using just the 2 arms?
We're not planning to have it free climb with just 2 arms. Our plan is to add legs so that it could climb in a very slow and deliberate manner. The pedestal that you see over on the display there is designed to go into the seat track on the side walls of the space station lab. What we are thinking, and we're open to ideas, but what we're thinking is that we'll build feet, modular feet on these legs that will be able to grip the various interfaces that exist on the inside of the station. So if you had 2 legs, one could be locked in and the other could reach out make contact, rigidize, and then let go of the other one. That would free the upper arms as it's climbing to be carrying objects, carrying wet wipes or carrying tools as it's climbing around the station. So it's kind of like rock climbing, but in rock climbing you're typically hanging on your fingers with gravity, and you're not really making a firm, rigid interface to the rock. You're just kind of hanging. In zero-G you have to make a more complete grasp of the object because there's no gravity bias. So the feet will need to be able to lock in to those seat tracks to stabilize the upper body as it climbs.
And then I guess this will be my last one. Can you elaborate a little bit on how those sensors work? I mean, are they specifically force feedback sensors in the joints, or do you have stuff within the skin? Because it seems like, and I half jokingly say this, that you guys have put a lot of emphasis on Asimov's 3 laws here, trying to make sure that there's no way that he can hurt an astronaut or vice versa. Can you explain how those sensors work with a little more detail, if it's not proprietary?
We have a lot of intellectual property that is coming out on the robot. We've filed over 40 patents. And so that will be coming out, and you'll be able to read about the patents. That's the nature of a patent, without giving away any of that information until the patents are filed. I can tell you that there are hundreds of sensors in this robot. And going back even to the Robonaut 1, there were 150 sensors per limb. So these are very sensate robots. With the Robonaut 1, we went through 4 different gloves with all kinds of skin-embedded tactile sensors, evolving the glove through 4 generations of gloves. We experimented with sensors under the skin to detect people, and in this design, the sensors are I could only say, more deep, that they're in the core of the machine, so we're able to detect the loads. But yes, sensing is very important to the machine. Hundreds of sensors throughout the whole robot. The control loop rates are thousands of times a second, monitoring those sensor signals and looking for accidental contact to make the robot safe. Our 3 levels aren't exactly Asimov's 3 laws, but we think that 3-layer safe is the way to go.
Okay, I think next we'll take some questions from Kennedy Space Center in Florida.
Yes, hello, Marcia Dunn with the Associated Press. First question I have is cost. How much money has gone into the Robonaut program, and how much is this individual robot worth by itself?
We think that about $2.5 million is the unit cost. I've never had the privilege of building robots in large quantities, so I'm not an industrial engineer. So I couldn't give you a better number than that for the case where we might make dozens or hundreds of these robots. But I can tell you, when I look at a Robonaut 2 and I look at my family car, the Robonaut has fewer parts, it has less material, and it seems that if you were to make Robonauts in the same quantities as you make that car, that the Robonaut should cost a lot less. Now, again, I'm not an industrial engineer, so don't take that estimate to the bank. But in quantities of 1 or 2, Robonaut 2s cost about $2.5 million.
Thank you. And another question I have is this the only Robonaut that will be flying to the space station? Or will you plan to fly another entirety to go outside? And if this Robonaut is the only one, or there are more to follow, will they all go down with the station eventually, or would you might hope to bring them back one day?
Well, so a couple questions there. Let me answer the first. At this point, we only have plans for this one, that we will look to fly upgrade components to the station. For example, giving it legs or a new backpack or a new torso computer. We would love to fly more in the future. We're looking at all sorts of missions beyond low Earth orbit, where the dexterous capability of a Robonaut system might come in quite handy. The second part of your question was, will it come home? At this point, we have no plans for Robonaut 2B to come back. I can't say what the future will hold. It may, ride the station into the Pacific, but we don't know where the station might go someday. So that chapter in Robonaut's life has not been written yet. We might take the robot, maybe that same one, beyond low Earth orbit in the future. It's got to earn its stripes first, though.
And lastly, is there any real-time control needed of Robonaut, or is this all programmable? In other words, if you need the robot to wash down the walls or the handrails, how do you get that command into the robot, and how much interaction from that point on is there with any crew or ground member?
So when we started working with General Motors, we went away from the teleoperation model that we had for the Robonaut 1. For GM, it really didn't make sense to have a person have to teleoperate the robot doing a task. You know, that wouldn't really buy you anything. So we wanted to build the machine able to do tasks on its own. So again, working with General Motors, we built a really nice interface, software interface to the robot that is essentially script-driven. Now the robot itself is very sensate, and it's sensing forces, it's reacting to forces, it reaches out and grabs objects, and it feels when it grabs them. But all of that is automatic. You start the script, it reaches till it feels the forces and does what it needs to do on its own without direct teleoperation.
Okay, I think that's actually about all we have time for today. We can find out more about Robonaut online at www.nasa.gov/Robonaut. There's a fact sheet there, as well as videos and photos. Coming up next on NASA TV, we'll have a quick look at some more B-roll for the STS-133 mission. And then at 2 p.m., we'll wrap up today's pre-flight briefings with the STS-133 crew news conference. All that's coming up. Until then, thanks and have a great day.
Good afternoon. Thank you for joining us for this afternoon's conference with the STS-133 crew. We'll start with opening remarks and then take questions. We'll begin with the introduction of Commander Steve Lindsey. Steve was born in Arcadia, California, and considers Temple City his hometown. He holds degrees from the U.S. Air Force Academy and Air Force Institute of Technology. He's also a retired colonel in the U.S. Air Force. Steve was selected as an astronaut candidate in 1995. Now a veteran of 4 space flights, Steve has acquired more than 1,200 hours in space. He served as the pilot on STS-87 and STS-95 and as commander for STS-104 and STS-121. We'll now turn it over to Steve to introduce his crew.
Thanks, Nicole. Let's see, just a real brief introduction of my crew. As I mentioned, I'm the commander. This will be my 5th flight and actually my 3rd flight aboard Discovery. We've had a great training flow. We're all ready to go, all trained. Just a couple of more things. We'll go into quarantine on Monday, and we're ready for a launch hopefully on November 1st if everything goes well. So real briefly, my crew, a pilot sitting next to me, Eric Bowe. This will be Eric's 2nd flight. He previously flown as pilot on the Space Shuttle. He'll be doing robotics on the shuttle. He's basically performing all the piloting tasks on the orbiter. Specifically, he'll be doing the undocking and fly around, and he'll fly some of the entry as we come into land. In addition to doing transfer and a whole bunch of other things on the flight. Next, Eric is Al Drew. He's our MS-1. He'll be flying on the flight deck for Ascent, and he'll be on the middeck for entry. Al's one of our spacewalkers, so he'll be doing 2 spacewalks during the mission. Additionally, he'll be flying the robotic arm with Eric and myself using the shuttle robotic arm for inspection tasks and all the other shuttle robotic arms operations that are planned for the flight. And this will be Al's 2nd flight as well on the shuttle. Next to Al, Tim Copra is our MS-2. He's our flight engineer on the flight deck for Ascent and entry. He's also our EV-1, or our lead spacewalker for the flight, performing 2 EVAs. In addition, Tim will be flying the space station robotic arm during a number of our different operations while we're docked to space station. Tim previously flew on space station in a long duration mission. Next to Tim, I've got Mike Barrett. And Mike is also on his 2nd space flight, having previously flown a 6-month mission on the space station. And this will actually be Mike's first shuttle mission. He flew up and down on the Soyuz as flight engineer, or essentially the pilot position. So he has a lot of experience with that, in addition to doing spacewalks in Russian spacesuits. On this flight, Mike will be our middeck captain for both Ascent and entry, running post-insertion deorbit prep.
He'll be flying the space station arm during a number of the operations while we're docked, as well as during both of the spacewalks. And he'll be doing a lot of transfer work and actually doing some maintenance and repair work on board the space station while he's there. Finally, last but not least, Nicole Stott. She'll be flying on the middeck for Ascent and on the flight deck for entry. Nicole's previously experienced with a long-duration spaceflight aboard the space station. Nicole's been doing a lot of the space station robotic arm operations. Additionally, probably her biggest job during docked ops is she'll be directing or running the spacewalks from inside the orbiter as the IV crew member. And so I've got a great crew. I've got a lot of talent. I've got a lot of experience on this crew. Something unique that we have is 3 veteran space station astronauts. So they'll be up there to keep us out of trouble while we're on board space station. So we have a great mission plan. Talked to the onboard crew this morning, just tagging up, doing some last-minute details. They're ready for us, and with a few more preparatory things to go. And so we're looking forward to having a great mission up there. And so with that, I guess we're ready to take questions.
All right. Thank you, Steve. We're going to start on this side. If you can state your name and affiliation, and we can start with Mark or Robert.
Oh, thank you, Mark Carreau, representing Aviation Week. I wonder, perhaps Steve Lindsey, or you can pick someone, but speaking a little philosophically about Discovery and the kind of condition you'd like to bring her back in. As I understand it, this orbiter is a candidate for display in the Smithsonian, or the Air and Space Museum, sorry. And just like to know what your thoughts are about returning it and what happens to it after your flight.
Well, we were actually down at Kennedy Space Center last week doing the terminal countdown demonstration test, the dry count, and talked to the folks down at KSC. And it's interesting because I've always viewed the vehicles as belonging to Kennedy Space Center, and they kind of loan them to us for a couple of weeks. And our job is to take care of them as best we can. And I always promise to bring the vehicle back at least as clean as we got it, which is pretty much impossible to do because they're pristine. I'm always amazed walking into these vehicles, you know, Discovery being, gosh, 25 years old, and you still walk in and it's like a new car. And so we're going to deliver it back, hopefully in the best condition possible, and take the best care that we can with it. And it's going to be a great vehicle. Historically, it's obviously a very historical vehicle, having flown all the return-to-flight test missions after both the Challenger and Columbia accidents. It deployed Hubble. It's the fleet leader in terms of number of flights. It'll have flown about a year on orbit by the time we're done with it, which is pretty remarkable for a space shuttle. Personally, having flown it twice and now on my 3rd flight, it has a special meaning to me. So my thoughts on when it comes back and when it's done with its service life, you know, they haven't made decisions on where these vehicles are going yet, but I think we all have a pretty good suspicion on where this one's going. But I just hope that when it's displayed, I would like to see it displayed in such a way that people that go and see it for the many years to come can get an appreciation for what it was like to fly it. From our perspective, you know, what it was like in the cockpit, what it was really like to operate, an appreciation for all the missions it did and all the versatility that the shuttle has offered. And in the end, though, when it really comes down to it, people are going to see the vehicles, but for those of us that have participated in the space shuttle program, it's really more about the people. When I think of space shuttle program, I think people, I don't think vehicles. And I think that's probably for all of us the biggest memory that we'll have out of this is the opportunity to work with a fantastic team all across the country over many years of this program.
All right, next question, Robert.
Hi, Robert Perlman with CollectSpace.com. Sort of work off that question and the answer. What does it mean to each of you personally to be on a final flight for an orbiter? Does it carry an additional significance? Is there an added symbolism beyond the goals that you have set out for the mission itself?
I've already talked. What do you guys?
I think overall, I think all of us are happy to be on another flight, get to go fly again. And for us, obviously, it's always nice. You know, it's a little bittersweet, obviously, when something's coming to an end. But it's a privilege to get to fly the vehicle. And Steve said it very well. It's really about the people. You know, we have Discovery, but there's thousands of people that make up keeping that vehicle flying and making it look the way it does and fly the way it does. So for me, that's really what makes this a great privilege to get the opportunity to go do this.
Anybody else want to answer that?
Well, I'm happy to chime in on that one too. I think, and it's a continuation of what these guys have said. It's that, you know, it is a historic thing, I think, that, you know, that we have such a special vehicle to fly. And, you know, the hope, in addition to having a successful mission, is that, in conclusion, we'll be celebrating just the real significance of the vehicle itself, and that includes the people, because it wouldn't happen without them. And I think that we have to look at this as a celebration of just how wonderful Discovery has performed, and just how fantastic the team that has put it together, you know, worked to make it happen.
All right.
Bill Horowitz, CBS. Well, I'll ask Nicole this question, or maybe Mike or Tim could also add. As Commander said, you guys are veterans of long-duration flights on board the station, and I'm wondering, what does that really bring to the table, or does it bring anything? I mean, when you get down to it.
We know where the bathroom is.
Yeah. How to use it.
No, seriously, what does past experience on the station help you guys with on a mission like this?
Well, I think, just to start, I think, and the fact that I think everybody here is an experienced flyer just kind of puts, you know, maybe a kind of a boost to the level of efficiency we'll start out with. The three of us certainly are, I guess you could say, intimately involved or intimately knowledgeable of the layout of the station, and how to get around, and where things are, and kind of the day-to-day operations that go on normally up there. But, you know, as a crew, I think we just will be in a position to just operate a little bit more efficiently right out, you know, right as we cross the hatch.
Yeah, if I could jump in a little bit on that, seen it from the other side, been up on the station a couple of times, and when you get up there and you're with a group of folks that have been on station for a long period of time, in terms of just moving around the vehicle, they go through a series of adaptations when you get into zero G, and when your first flight, when you first get up there, you're just bouncing all over the place because you don't understand how little force is really required to move around. You get better and better, but you never really achieve a high level proficiency on a short duration flight. If you watch a space station crew member move around on orbit, their ability to get things done in a very efficient and effective manner far exceeds what we can do. And you really notice it when you're working next to somebody that's been up on space station for a few months, that they can do things so much faster and so much better than you can. So I think they bring that to the table. All of the things that kind of the bread and butter of what we do in day-to-day operations, you know, when we have to do different photography things, when, you know, hooking up electrical components, working the computers on space station, which are similar to Shuttle but different. They work different, the systems are different. Having all that knowledge built into the crew, I've never actually been on a crew where we had space station experienced folks. So I think, but with all of that, they can answer all the questions that we're not sure about, and so I think it brings a lot. I mean, we'll see how it goes, but I think it brings an awful lot.
Like how to work the bathroom? No, I'm kidding.
That's actually very important, and they do know how to work it, and so yeah.
One more quick one for me for Tim Morale. I was confused in the EVA briefing about where you guys are when you're venting aluminum, when you're venting ammonia. You're up, I guess, right by the pump module on the front side. I didn't know where Tim was. I just wanted to know where you guys were.
So if things go per the timeline, I'll be crawling over the top of lab and heading towards Columbus. So I'm going to be well clear. In fact, ideally, if we had it to synchronize in another way, I could be in a position to take photographs of the venting. But by the time I get to my location, I think the venting is going to be complete.
Thanks.
Sure.
Jill Tolk with the Bay Area Houston Magazine. A similar question to Bill's first question for the past station crew members. Things are going to be a little bit different. Obviously, you're not going to have the marathon equivalent of a space flight. You have a sprint because you're on shuttle, and this time you will have cupola. So you will have a bit of fun challenge, a difference. It'll be a different flight. So what thoughts and feelings do you have about that, where you'll be able to have a bit of a different flight this time, a different experience?
I'll take that to start with. You know, we often use those analogies, marathon versus sprint. I want to remind people that a marathon, you're still running. And 6 months of running, you get more efficient at it, and you actually cover more ground at the end of a day after, say, 3 months up there than you would at the very start of your race. I was surprised how little free time we had on our station mission. After 6.5 months, we were still working very long days. So I wouldn't call a station mission leisurely in any way, shape, or form. I think for all of us, we're looking forward to a larger station, and you mentioned the cupola. And certainly most people would agree that the best use of any downtime you do get, which is very little, is to be looking out the window. And even that, you're typically using a camera and trying to take pictures of geological sites of interest. But I think most of us can't wait to see the cupola. For Tim and Nicole and I, we'll be doing a lot of the robotic ops with the station arm, and that is currently the robotic workstation place du jour. So we're very much looking forward to doing business out of there and relying a little bit less on our camera views and a little bit more on direct line of sight.
Gina Sinceri, ABC News for Eric. Eric, what are you looking forward on this mission? It's your second mission. I mean, like they said, no one's a rookie anymore, or not a rookie, but not, you're all experienced. But what's going to be the highlight of this mission for you?
Well, the highlight for the mission for me is actually, you know, the first time you're up there, things go pretty quick. I'm sure it's going to go fast this time as well, but I think I'll have a little bit more time to look around and kind of pay attention to the small details to really, you know, soak in all the things that are happening at the same time. You know, just like the last flight, I'm going to enjoy just, again, working with the control teams. You know, it's a big team effort to get the job done. So to me, that's always a fun part. And obviously, getting the opportunity, Mike had mentioned it, looking out at the cupola, look out the windows and see the view out there. But I think the biggest overall thing that I hope to get out of this is just to really absorb some of the smaller details that I may have missed on the first flight and see new things.
Eric Berger with the Houston Chronicle. Question for Steve, or maybe Tim, Mike, or Nicole, people who've been to the station before for some time. When y'all leave, you're going to be seeing the station in its final configuration with the last module attached to it. So maybe one of you could talk about sort of seeing the station at different points in its evolution, then getting to see it in its final form as you fly away, and really sort of be the first crew to do that from an external viewpoint.
I can give you one impression I had as I left on STS-128, and having spent a long time like the rest of my crewmates, especially the ones that were in our astronaut class waiting to fly, you know, you go to program meetings, you work with hardware vendors, and you work at Johnson Space and other NASA centers to build this space station, and to be able to see it all working together, this really like a flying city in space, is almost overwhelming. And for all the hard work and sometimes conflict and consternation, it's really great to see this beautiful piece of hardware that's flying in space. And so I'm looking forward to seeing it with a few more components, and like Mike had talked about from the inside, being able to see outside the cupola.
All right, Greg.
Hi, Greg Dobbs with HDNet Television. Steve, your first answer to the first question was that you always try to bring a vehicle home in the same condition in which you left. It may be a weird question, but if somebody didn't think that way, didn't operate that way, what is it that could be done to a vehicle so it wouldn't come back as good? You know, what is it you're going to do to make sure it does?
Oh, well, gosh, a whole bunch of things. I mean, first and foremost, we, you know, in every activity we do on the shuttle and every procedure we do, we have procedures that we follow and in ways of doing business, and we want to make sure we always stay doing those things correctly. In terms of the vehicle itself, you know, housekeeping, believe it or not, is a really big deal when you're living, you know, it's like living in a Winnebago for 14 days, and you want to keep it clean, and so housekeeping is a really important part. So we try to take really good care of it, try not to do anything with it we shouldn't be doing, and make sure we follow the procedures. And you know, it's what I just said is what every crew thinks the same way, is they just want to bring it back as good as possible. In the past, it's you know, it's always because we're going to turn the vehicle and we're going to use it again. This is a little unique because it's the last time we're going to learn use the vehicle. But you know, if we were to land and all of a sudden the whole world were to change, we're going to get ready to fly it again. For some reason, it would be ready to fly again, and so that would be our objective in bringing it down.
All right, over on this side.
Philip Sloss with NASASpaceflight.com. I'm not sure who this is for exactly, but your mission has changed from when it was originally, when you were originally assigned. This was going to be an 8+1 day mission, no EVAs, and now you've had 2 EVAs added and 3 flight days. Could you talk about the changes that have occurred during the training flow and kind of, you know, what's happened with that?
Sure. You know, we started out, we were going to be the final flight in the Space Shuttle program, and the objective of that final flight, to make it really simple, so somebody like me can understand, was basically leave space station in the best possible configuration, which means get the maximum amount of upmass to station, the supplies they need, because it'd be the last shuttle flight, and leave in the best condition possible. So we're going to go up, drop off our stuff, and undock as soon as we could so that we didn't use any of their resources. Since then, we are no longer the last flight. The flight before us had some payload changes, so they moved behind us, and now, you know, at least in the authorization bill, they've added that additional flight. So our objectives have changed. By the way, going into this as an 8-day mission, I never thought we'd ever stay an 8-day mission. I always thought we would pick up a spacewalk or 2 because things change, things break. We have different objectives. So the program's added in a couple of spacewalks to do basically some cleanup objectives, some things, what we call homeless tasks, EVA tasks that need to get done but didn't have another place, so we added those in, returning a payload. Then recently when the space station had the pump module failure and they had to do the replacement, we're doing some cleanup actions, going to vent that, move it back into place, and get ready so that they can bring it home, hopefully on a subsequent mission. So we're picking up all those tasks. It's been a challenge because we added those tasks fairly late in our EVAs. The content changed very, very late, but we were kind of prepared for that. We had some pool runs kind of held in reserve that we knew we were going to do, probably get new objectives. Tim and Al did a really good job training. I think they focused on more of a skills-based approach early on so that they could go and pick up those additional tasks. For example, they looked at tasks, they thought, well, this may come on our flight, even though it's not. And so I think they were well prepared when those changes occurred. So we've had a lot of robotics change, a lot of EVA changes, but I think we've adapted to it pretty well and trained to it. So that's part of the business. You need to be able to react to changes. You need to be able to react to failures, just like the space station does and just like they did recently. And so it's kind of how we've changed our approach over the years to be able to handle this anyway. So.
Hi, I'm Mark Kirkman, Interspace News. First question for Steve. I understand you had, I think, your final entry sim this morning. I was just wondering if you might be able to give kind of an insider's look at the horrors you faced this morning and what some of the remaining training requirements you have between now and heading to the Cape, and then a follow-up for Ben.
Insight on the training that's left?
Yeah, what major events you have.
Oh.
And also what you faced this morning, what it was like to be in
Oh, well, we did our, to start off, we did our last entry simulator this morning. We did about 4 runs. We do various runs, but these 4, we all started from 200,000 feet, so kind of about Mach 17, 18, 19, somewhere around there. And you know, they throw various failures at us, computer failures, reaction control system failures, electrical failures, you know, and it just forces us to work as a team with us in the ground to go through those. And all those runs went great. And then the very last run was probably the most important run. We took it down all the way to the ground, and then we did what's called post-landing. After we land the shuttle, we go through about an hour of reconfiguration of the vehicle, working with mission control to get the vehicle safed and configured so that we can actually exit the vehicle. We actually went through all of those procedures to practice those one more time. As far as remaining training left, we have some photo, TV type training to go, some review of some systems and computer systems and a few other things. We have some medical tomorrow, our launch minus 10-day physicals and a few other things like that. We'll go into quarantine on Monday, and we'll do a few more review classes. We have 1 Ascent sim left with our Ascent team. And then after that, we'll fly down to the Cape, and we'll be ready to go. So there's very little training left. Mostly it's a lot of administrative things. We're trying to, you know, personally prepare for going into quarantine and leaving our families for, you know, 3+ weeks at least. So, so that's kind of where we are now. So we're well ready to go.
And then if I may, a question for BIM. I actually think I remember you as a cadet in CAP, and I was just wondering if you can maybe comment on what an organization like that how it might influence someone to be able to do great things. Not that looking at you back then, I thought you were a future shuttle pilot, but somewhere there might be one in CAP today.
So you're asking about CAP, which is Civil Air Patrol for everyone else that's out there, and it's an auxiliary of the Air Force. And they have a cadet program and obviously a senior program, and I was involved in the cadet program very heavily. I'm still a member, but what I enjoyed about as a cadet, for me, I was very interested in aviation. So there's an opportunity they gave me the opportunity to obtain my solo license, gave me all the flights and the training necessary to go do that. I was from Georgia. We did a lot of search and rescue. And so it was a lot of these things, a lot of the teamwork, a lot of the flying and aviation skills, and also just my passion for aviation kind of got fostered in Civil Air Patrol. So to me, it was a great program as a kid to get involved with and learn a lot of different things about that. That answer your question?
Okay. Jim Oberg with NBC. A quick question to make sure that, have you all found time to vote?
Oh, yes.
We're all early voting. So
all early
actually,
voting.
I voted yesterday morning. It was a short line, so
Oh,
it's probably going to get longer.
And a more serious question about last things is that we know the flight crews always encourage the ground support groups, the teams, their trainers, operators. And you're always deeply involved in encouraging these people. You're facing a double challenge now that many of the people you're working with now probably won't be here 6 or 12 months from now. What kind of special things are you doing to encourage people who are, without any fault of their own, approaching the end of their NASA careers? How are you helping them keep up their spirits?
That sounds like a difficult question. I guess I'll try to answer that. Yeah, it is a difficult. You know, we were down at Kennedy Space Center last week, and it was about a week or so, maybe a week and a half after they took 1,000-plus layoffs. We took 300 and something here, I think, and more to come. And it's a very difficult time. The thing we noticed with all the people we're working with, all the teams we're working with, is even with those layoffs, everybody's very motivated to see this program through and see it through successfully. Eric and I were actually talking about this yesterday a little bit, you know, it's really interesting that you're, you know, you come here and you realize after you've been here for just a short time that the workforce here and the other centers is very special, because these people aren't here because they're getting paid more than you would in any other organization. Matter of fact, probably particularly in Houston, you know, for an engineer, you're getting paid less to work here. But people are doing this because they love it. So to watch program winding down and watch people losing their jobs is tough, but they're all very motivated to do the right thing. So from our part, what we do is we do our best to continue encouraging those folks, thanking those folks for what they do, participating in their events wherever we can, whenever we can, in trying to encourage them. And you know, the one thing that I've told several groups that you know, reaching the end, I said, you know, it's true for us too, because when the shuttle programs goes away, we won't be a part of it either, and our own office is shrinking as well to go with it. So it's kind of sort of happening to all organizations. But you know, the one thing that I like to tell folks is that, you know, you're part of a very special team, one that you probably won't ever see again. I mean, there may be a team for the new vehicle, whatever that is, and it'll be a good team, but it won't be this team. And if nothing else, you know, you can look back, I think, with a lot of pride on what we've done over the years with the Space Shuttle program and building the space station and the Mir and all the satellites we did before that, and all the things we did with the Space Shuttle. And so we like I said, we do our best to encourage people. Now, that doesn't give them a paycheck, and there's not much we can do about that, but try to encourage folks and help folks where we can is about, you know, about all we can do. So.
I believe we have someone.
Haley Kappas with the Galveston County Daily News. Al, can you tell me what it's like going, or what your thoughts are going into your first spacewalk, and kind of give a picture of what training has been like for that?
Just feeling very lucky right now. Like Steve mentioned initially, that our flight didn't have any spacewalks scheduled when we first started. Tim and I were scheduled for contingency spacewalks, but we're never sure that we're going to have one. So when the opportunity arose to pick up some of these homeless tasks along with the cleanup from the pump module failure, it was a great opportunity to go out and help out the program, and of course go outside and look at the universe from outside of a vehicle for a bit. Having said that, I think a bigger part is feeling like you can make a big contribution to the program itself. There are things out there that we can do. We've got special training to go do, and it's going to keep the space station alive longer. We're trying to extend it beyond its original intended lifespan, and to hopefully look back in 2020 and see it out there working, and to think I had a small part in keeping it going that long, I think will be the big part I'll take back from this.
Carrie Feibel, Houston Public Radio, and also on behalf of Austin Public Radio. Mr. Copra, I wanted to, as someone who's from Austin, I think a lot of Texans are going to be keeping a special eye on you. And I wanted to find out from you a little more what your feelings are about being one of the last few people to be on a shuttle mission. And also, what would you say to students who, during this time of transition in all the programs, who still want to be an astronaut, who still might want to be an aerospace engineer? What would you tell them?
Sure. Well, I think like all my crewmates here, we all feel very privileged to be part of this mission. And we also feel like we have a lot of responsibility to do the best that we can to put space station in the best possible condition before we leave. So we're both very privileged, but also, we feel the responsibility to do the right thing and work hard and do a good job for everything that's planned on the mission. In terms of what young people think in terms of their aspirations to do big things like be an astronaut or some other large goal, I would say that the primary thing that any young person needs to think about is their big goal and working towards that. And in large measure, it's not so much the goal, because I feel very fortunate, like all the folks in our office, to have this job. But I think one thing I've learned along the way is the path is as important, if not more important, than the goal itself. So anytime young people work hard in academics or their extracurricular activities and they excel, I think it just increases their possibilities in the future, and they should just continue to work hard and dream big.
Okay, with that, I think we'll switch over to Kennedy Space Center, where we have a few reporters as well.
Yes, hi, Marcia Dunn, Associated Press. We just heard from the Robonaut briefer that he spent 20 years going around asking people what they would do with a robot if they had one. So my question for the three former space station residents is, if you had had a robot aboard the space station with you, what would you have had him or her or it do? And how do you see Robonaut as easing the burden for future crews?
Well, hi, Marcia. That's a really good question, and I think we see Robonaut, as the program does, as very much a technology demonstrator. It's the first time we've had a humanoid-shaped robot for spaceflight, and that conjures up all sorts of uses and things well beyond what we've got envisioned for it quite yet. So I think that's the important thing, is that this is a very much first step. And we will be identifying some breadboard tasks over the next few years to figure out how best to use a humanoid robot in space. When you look at some of the tasks that we're asked to do and what a robot could do, you're thinking of things that would be perhaps dangerous for a human to do, or repetitive tasks that would wear a human out. So if you were to go around the station, for instance, and identify scenarios where it was risky to send a human in, whether you had a suspected fire or a toxic release, and what you needed was a switch throw or to discharge a fire extinguisher into the right fire port, that's the kind of thing we could eventually envision sending Robonaut in to do. A couple of those scenarios, I'd much rather send a robot in than go in myself on a gas mask. But again, we're very early, and we'll be mapping those tasks to the capabilities that Robonaut demonstrates over the years. And it will be years before we figure all this out. So we're excited to see this all start.
Thank you. And if you had to have unloaded one of the more unpleasant, mundane tasks while you were up there for months, what would that have been?
Nothing that Robonaut, nothing that Robonaut has the dexterity for at this point. I can put it that way.
It's funny, though, up there, nothing seems really all
I
that
think I get your
mundane.
picture. And I have a question for Colonel Drew. I'm just wondering if being an astronaut was something you've aspired to throughout your Air Force career, whether it was there with you from boyhood, and how you've gotten to this place in time now, today.
I didn't really aspire to become an astronaut until I was at least 5.5 years old. By that time, I gave up my dream of being a pilot and decided to go pursue that. I was watching the Apollo program back then and thought that was something that looked like it was more like fun than work. I've since learned otherwise. It's still fun, but it's still a lot of work. that was one of the things that was in the back of my mind during my Air Force career, but nothing I really took that seriously. I think betting your career on becoming an astronaut is like planning your pension around winning a lottery. And it's something you can go pursue, but you sure have a plan B in place. So I did everything to make it to stack the deck in my favor, but never really expected it was going to happen.
Hi, it's James Dane from Florida today. And similar to Marcia's question about Robonaut 2, I wanted to ask the same for those of you who've had experience on station about how the addition of the PMM might have been welcome, just adding that closet, as it's being called, or extra storage space.
I think it's going to be a really outstanding addition to the station. I think anybody that's lived and worked up there has, at one time or another, or many times, felt like, wow, if we just had a closet where we could stick this, or we just had, designated storage for these particular items, it would be such a great thing. And I think what it's going to do is it's going to provide that, but it's also going to give us the opportunity to go through station and look at where we have stuff and maybe better distribute so that we make even more space available. So I think it's going to be a really, really nice addition.
Thanks, Nicole. If I could stick with you for a moment, we've been trying to occasionally follow Discovery's processing flow as it's getting ready for a final flight. As someone who's intimately familiar with that process, just wondered if you could speak a little bit to what it takes to, and you guys have talked about the thousands of people involved, what it takes to turn around a vehicle for flight, and to the extent you've been able to follow it closely, if there's anything unique that you've seen during Discovery's flow.
Well, I think as it goes for any vehicle down there, it's a complex thing, and you move from the runway back to the orbiter processing facility with the orbiter itself, and then in parallel with that, you've got all this work that's going on in preparing the boosters and the external tank, and then ultimately bringing it all together. But I think we always have to go back to the people on this, because when I work there and now when I get the chance to go back, it is so impressive to me to see how just cleanly it all does come together, for as complex as it is. And you can take just one little part that's in the aft part of the orbiter and look at the complexity of that and see how nicely it comes together, and then look at these, these four big pieces, the shuttle and the two boosters and the tank sitting so beautifully together at the end and ready to launch. And it's really an interesting process, and it all comes down to the people that are there that know how to do it and have, like these guys have said, a real passion for making it happen. And as far as anything unique and what's gone on, I don't know that there really is anything this time to point out. I think for us, it's just always a real pleasure to go down there and see the milestones, the kind of the steps that are being taken to make the vehicle ready for launch. And when we were down there last week for TCDT, or for our practice count, it's another one of those impressive times where you stand at the base of that pad and you look up at this beautiful vehicle, and you just give a big thanks to the people and are just really happy to know that you're going to be strapping in there in a couple weeks and getting to launch. So I hope that answers your question.
That's great. Thanks so much. And there's just a couple of final questions for Commander Lindsey. I recognizing there may be an additional shuttle flight added, but knowing that there's only 2 remaining now, I just wondered if, was it in fact kind of a relief to you as the leader of the mission when this mission became no longer the last shuttle flight, in terms of just knowing all the added attention and stress that might add to getting ready for a flight, and now another crew is going to have to deal with that?
Gosh, I never really thought of it as a burden. Honestly, my feelings on where we flew where we are in the manifest is, we were originally selected to be the last crew for the last flight. When it moved, it's never been about us. It's always been about the program, what's right for the space station, what's right for the space shuttle program. So when we moved out of that position, we're happy to serve wherever we can best serve the programs and get the objectives done. So it wasn't, whether I was the last flight or not the last flight, I didn't really feel, honestly, when we were the last flight, I didn't feel any additional pressure associated with that. Maybe I should have, but I really didn't. So it's kind of a wash for us, I think. But we're happy to be flying together. We're happy with our objectives, looking forward to the mission. And so personally, I'm really excited to be flying with this crew. I love all these guys and girls, and they're a fantastic group of people to fly with. Somebody once told me when I first came into the office, you'll find as you get more experience, it's less about what you do on a mission and it's more about who you get to fly it with, and I think that's really true in this case.
Great, and you mentioned earlier that the astronaut corps, like other parts of the program, the agency, is shrinking a bit as the program nears an end. Being a former head of the office, can you tell us what the Corps is going to look like after shuttle flyout is complete in terms of numbers and how you move forward?
Well, I can tell you what we do to size the office. The office has always been sized based on the manifest requirements. In other words, who we need to fly when, how often we need to fly. So we were always sized for, shuttle and station, and then when station went to 6 crew, we needed a bigger crew to support that. And then, so we planned the sizing to support the manifest plus a pad to deal with, somebody who maybe doesn't get trained all the way in a certain system, like spacewalking or robotics, and we also plan to deal with unexpected medical conditions. And so that's how we size the office. We did size the office for shuttle ending and space station at 6-person crew, and then the addition of the Constellation program when that was and so we planned our sizing for that. So I think the sizing in the future really depends on what the program looks like, not the ISS program, but the follow-on next vehicle program. And so I know that right now that they're looking at the sizing, and they'll calculate what size office we need based on those manifest requirements. So it's a constantly somewhat changing target. We will hire early to try to prepare for that. We don't always get it right, because if the program doesn't fly exactly on time, then we may have too many. If we come up to speed earlier and we don't hire soon enough, then we may not have enough. And so we try our best to plan for that and hire according to that so that we have the right numbers of folks to accomplish the mission. So I can't give you a specific number because I haven't been doing that for the last year, and I'm sure probably the current division office and flight crew ops can probably elaborate a little bit better on where they are. But that's essentially the process that we use to decide the size of the office.
Todd Halverson of Florida Today, for either Steve or anybody who wants to take it. I was curious about what you folks thought about the commercial crew transportation program, shifting the responsibility for launching astronauts from NASA to the private sector.
Anybody want to take that? I guess not. No? Okay. Another hard question. I get to take that one. Well, I think it's a challenging time in terms of what we're doing with that, and haven't been working on it the last year because I've been training for this mission. To go from essentially government oversight to government insight, it'll be an interesting transition we have to go through and a real challenge for us, because we have to figure out what you want the commercial companies to succeed, and you want them to be able to do it hopefully cheaper than what we do it, how we do it, and that's one of the motivators for doing it. But the challenge is making sure we maintain the safety. So I guess when I put on my old astronaut office chief hat, what I look at is I think the devil's in the details here, and it's all on how we implement it. How much insight is the right amount versus oversight. And so I think from an office perspective, what we'd be looking at with that transition to commercial is first and foremost the safety of the process, the safety of the vehicle that we fly, making sure that it meets our human rating requirements. And so I think the way we're approaching this is in terms of how we handle the human rating requirements to this new set of contractors, if you will, that will be providing this new vehicle to us. So I don't know if I answered your question very well, but it's very much a work in progress, and I think the key is how we do it. So I don't think anybody's against doing it. It's just a matter of how you implement it, and implement it smartly, safely, and effectively.
If I could give a big picture spin on that as well. We're kind of fixated right now on the next steps that we're about to take. But as an office, I think you'll find down to the last person in our office, we're all very pro-NASA, but more broadly, we're very pro-human spaceflight. And I think if you look at the long run, most of us would agree that the more human spaceflight, the better. And whatever means out there help us to accomplish that, because there's so many reasons for us to get off and explore and expand, then we're in support of that, no question about it. So if this becomes one of the logical next step, again, from a big picture standpoint, then we're going to be very supportive of it. And we're going to offer as much help as we can individually.
Thanks very much. Let me give Steve an easier one. I was wondering if you guys have nicknames for each other, and if you do, what they are and why.
Not as far as you know. No, I don't think I can say anything here that wouldn't get me in trouble. So I think I won't.
It wasn't as easy as you thought.
Yeah.
That was the easy one too. Let me try one more, and this is for Steve. You mentioned that you've flown Discovery twice, and this will be your third flight. I'm wondering if the vehicle has personality of its own, and if it does, how you would describe it.
Oh, that's a good question. I think they do. I've flown Columbia, Atlantis, and Discovery, and it's probably just imaginary, but I think they fly differently. And you know, to be specific, I think Discovery. Well, Columbia flew different than either of the other two, and I think you can explain that because it was a lot heavier. It had tiles all over it as opposed to thermal blankets, and I think all the handling qualities of Columbia were just a little bit different than the other ones. It flew like it was heavier, quite frankly, from what I remember. I think, interestingly enough, I think Discovery has a little bit wilder ride on Ascent. It just reminds me that the motions that you feel as you're going up, I mean, the trajectory is the same, it looks the same, it flies to the same cutoff conditions, but it just seems to be a little bit wilder, a little bit wilder ride on Ascent. I think Atlantis is a little bit rougher ride on entry, specifically in Atlantis. When you hit, typically in all the vehicles, when you hit the Mach 1 point, you get this buzzing that goes through the airframe as you slow from supersonic to subsonic. And you notice it on Discovery, but it's not very much, and it doesn't seem to be very long. At least the last time, a couple times I flew it, it was like that. Atlantis, it has this buzzing that, at least on that flight, went on forever. And it may have been associated with the weight of the vehicle or the center of gravity of the vehicle, but to me, they fly a little bit different. So I think the personalities are a little bit different, how they feel, how they fly. They all fly great, they all handle great, but they're just slightly different. So you can tell. There's some switches that are different, but very, very small deltas there. But they just handle a little bit different to me. So I guess that's how I describe the differences.
All right, with that, we will now switch over to headquarters where we have a reporter with questions.
Hi, this is Denise Chow from Space.com. One of the other milestones that will happen if your mission goes on with the proper timeline is that the 10th anniversary of Expedition 1 arriving at the space station, and especially for the members of the crew that have spent significant amounts of time on the station. I was just wondering what that milestone means to you and for the future of the ISS.
I guess I'll start out. You know, it's really interesting being able to fly on a shuttle in a shuttle mission after being on station. And you know, all of us have watched from the very beginning when space station crews first started, and actually the rigor that they went through for their training, and what they had to experience when they were on board. And I guess one thing that I noticed over that time is that both the quality of life in training and quality of life on board space station has continued to improve. And that's a great thing. I think we're learning how to live in space, and every step and every crew is doing it better and getting smarter, and the program is getting smarter. You guys have anything?
I think one thing is to say thank you to them, because I think from the very beginning, starting with this, you know, significantly smaller volume where you had these 3 guys living up there, and working as an international crew, working on a vehicle that had even at that size had been built from that point on successful international program. It just was such a great starting point for all of us who now get to experience this ginormous volume and still sharing in this really spectacular international program that has made it such a success.
And just a follow-up question for Steve. I thought it was really interesting how you were talking about the differences of the various shuttles that you've flown on. And I was just wondering about Discovery in particular, if you've noticed differences between the first and the second flight that you've taken, and to your knowledge, the upgrades that have been made for this upcoming mission, if it'll feel different for you.
I don't think it'll feel different. The first flight on Discovery was not to space station, and we actually had a space hab additional science module in the back of the payload bay. So it was a lot heavier, and the mission was a lot different. It was a lot shorter. Second mission, we went to space station, and we were a little bit lighter, and we had the power transfer, or we didn't have the power transfer system yet. We will in this flight. But in terms of how they flew and how they operated and acted, basically the same. What was unique, the first flight I flew Discovery, we went really high. We went up to Hubble altitudes. We were up at about 360 miles high, and in a different orbit than space station. And the view of the Earth from that different orbit is just altogether different than what it looks like off a space station. And so that's probably, if you want to compare those two flights, for me, the different altitude really made a huge significant difference in how the Earth looks. At the altitudes we were flying, the Earth looked a lot smaller and a lot rounder, which you wouldn't think a difference of, gosh, what was it, maybe 120, 130 miles makes, but it really makes a big difference when you're up there.
All right. Thank you very much, Steve, and thank you for everyone joining us. That concludes our briefing. For more information on the STS-133 mission, we encourage you to look at our website, www.nasa.gov/shuttle. Thank you.